So if you guys didn't know before you logged in, this is how to perform roof inspections. And the goal of this course is to teach inspectors how to inspect the roof covering system in a home. And that's going to be a big thing today. We're just going to I'm a little bit nitpicky about terminology when it comes to roofs. Roofs are my favorite part of a home inspection. I'm kind of a roof specialist if you don't know who I am, but we can kind of get to that later. So let's jump right into it. And we'll talk about the standards of practice first, like we always should. So, according to the InterNACHI Home Standards of Practice, Home Inspection Standards of Practice, the inspector will inspect, and that means you shall inspect. It means you do inspect according to these standards of practice. The roof covering materials, right? Is it shingles? Is it metal? Is it tile? The gutters and downspouts, which is really the drainage system. So, if you're talking about a situation where maybe it's a flat roof and you've got scuppers or something like that instead of gutters, you're going to inspect the drainage system of the roof. The vents, the flashing, the skylights, the chimney, and other roof penetrations, and the general structure of the roof from the readily accessible panels, doors, or stairs. Okay, the inspector shall describe the type of roof covering materials. The inspector shall report as in need of correction observed indications of active roof leaks. Okay, the inspector is not required to walk on any roof surface, predict the service life expectancy, inspect underground downspout diverter drainage pipes, remove snow, ice, debris, or other conditions that prohibit the observation of the roof surfaces. You're not really required to move anything, right? So you're not required to move insulation, inspect antenna, satellite dishes, lightning arresters, de-icing equipment, or similar attachments. And you're not required to walk on any roof area that appears, in the opinion of you, the inspector, to be unsafe, right? Which you're not required to walk technically on the roof anyway. So if it appears unsafe, that's sort of a double. You don't need to do that. And then you're not required to walk on any roof areas if it might, in your opinion, cause damage. You're not required to perform a water test. You're not required to warrant or certify the roof. That should go without saying. And you're not required to confirm proper fastening or installation of any roof covering material. So again, if it looks improperly installed to you and you're aware of why, you can obviously call it out. And like we always say with the standards of practice, this is like kind of like a building code situation where that code is the minimum requirement for a builder or roofer or plumber or anybody to meet in order to be okay doing what they're doing. But it doesn't mean that that is the roof, right? That's the floor. It's not the ceiling. It's you can go beyond the standards of practice. But if you're going to be InterNACHI certified, which I hope you guys all are, pursuing CPI if you haven't already gotten it. But if you're going to maintain an InterNACHI certification, these are the standards of practice, the minimum standards of practice that you have to abide by in order to remain certified through InterNACHI. So all these things that say you're not required to do, it doesn't mean you shouldn't do them. It just means you don't have to in order to meet that minimum standard, right? So next, we're kind of skipping these videos, but I'll just kind of piggyback on what I know Ben talks about in this video. Roof inspections are dangerous, right? So any inspection, anywhere, anytime, no matter what you're doing, safety is the utmost concern, right? So you're not required to walk on the roof because it's by nature an unsafe thing. I think the statistics in construction deaths every year, falls off of ladders or roofs or high areas are really some of the leading causes within the top two or three pretty much every year. Now, statistics are fun to play with because technically the most deadly thing you can do on a job site is to walk up a ladder 30 feet in the air or something like that. So, is cutting yourself with something or stepping on a nail necessarily deadly in most circumstances? Hopefully not. But all that is to say, it is a very dangerous thing to do to get up on a roof, but I don't want that to scare you out of doing it. The real question to bring up is how do I do this safely? And again, if you don't know my background, I've been a roof consultant for 17 years at this point, almost 18 years, and I've trained hundreds of roof inspectors. And the thing that I always tell them is when I get to a situation that looks a little sketchy, it's not a matter of am I scared to do this? It's more just a matter of how much time is it going to take me to do this safely? Because I'm married and I've got two kids and I need to go home to them in the evening. So it's always a question of how to get this done safely. And if the answer is there is no way to get it done safely, then the answer is you don't do it, right? So hopefully that goes without saying, but we'll talk real quick on that note. Safety standards in walking the roof. An inspection of the roofing system is both one of the most crucial areas of the home inspection, which I'll also touch on because it is highly important and I do recommend it, and one of the biggest concerns on the prospective homebuyer's mind. Spending a large portion of the inspection time dealing with the roof and following some basic rules will pay dividends to the inspector, both in terms of customer satisfaction and also in reduced liability. Now, why does it say that? Think about it. The exterior building envelope, as it's called, the walls, the cladding, the roof, and all these things, they are designed to take moisture and get it away from the house, right? So rainwater comes down, get it away from the house. Humidity comes about, get it away, stop it from infiltrating the house. Well, the roof, as I like to call it, is the umbrella of the home. And so whenever there's a rainstorm, whenever there's snow, there's ice, and all these other things, the roof is your primary protection, right? Because if you can have a leak in your wall, that's not definitely going to be a leak that you see inside. But if you have a leak in your roof, almost 100% of the time, that's going to be something that penetrates over the course of time and eventually starts to put at risk some of the most valuable things that you keep in your home. So it's very, very, very important that you do a thorough roof inspection and that you educate yourself by taking courses like this and InterNACHI's other available courses. And I would push you maybe to even study further on how roofs are built, how they're put together, and where they typically fail. So that is such an important and critical component because moisture is the biggest enemy of a home, as I'm sure you guys already know. There's obviously any of the trades is going to say, well, electrical is, you could burn down the whole house. And there's every component is obviously important. And as a roof specialist, obviously I'm a bit biased towards inspecting the roof, but I do believe that from a protecting your investment standpoint, there's nothing more important than you can know than what the condition of the exterior building envelope is. And that starts with the roof. But safety first. So before approaching a roof inspection, it's important to keep safety at the forefront, like we just touched on. Too many home inspectors and other tradesmen have been seriously injured by being lax with ladder and roof safety. And I've personally witnessed it. It hasn't happened to me, but I've seen a lot of people do it more than I wish that I had. And, at least one of those scenarios ended with somebody losing their life. And so it's very, very serious that you guys do it. I encourage you to do it, but make sure you're educated on how to do it first. Don't just say, well, Matt said, I got to get the roof inspection done. Well, you got to get educated on how to do a roof inspection and then don't miss out on the roof inspection portion because it's such a big part of the home inspection. Some roofs should not be walked on. One of the first safety issues to consider is that some roofing systems simply shouldn't be walked on. In particular, the most types of solid tile roofs and all wooden shingle and shake roofs can be accidentally damaged by the inspector. In addition, all types of roofs should not be walked on if conditions are wet or icy or if the roof is mossy, covered in algae. If you haven't seen that, especially on asphalt composition shingles, but other roofing types as well, it'll be a black, streaky look to the roofing material, and that algae gets very, very slick when it's wet. And it's basically there's no walking on it. There's no amount of anything that you can do to stay on it if it's wet. And some roofs are just too steep. Now, the steepness that I'm comfortable with is not going to be the steepness that you're comfortable with because I'm a roof consultant. So you have to kind of decide on your own what is a threshold above which I'm just not willing to inspect a roof. And I would encourage you to disclaim that in your report and go about other means. And we'll talk about drones as part of this course as well. Even when considering walking a dry roof or a roof of low slope that's just one floor up, it is important to keep safety in mind, and sometimes more so because you get into a false sense of security when you're on a 6 pitch and it's 1 story off the roof. If it's a 12 pitch and it's 3 stories high, I guarantee you'll be taking every safety precaution possible, but a lot of guys get too comfortable on lower slope roofs where they can kind of just trounce around like it's the sidewalk, right? So when all other conditions appear favorable and safe, it's still possible to put your foot right through the asphalt shingle roof covering of a house due to rotten roof sheathing. Remember that most of the time, a roof covering can be inspected from a ladder at the eaves, from the ground with binoculars, from overlooking windows, or currently drones. When planning to walk on a roof covering, remember to wear soft-soled sneakers or similar footwear, as they may offer far superior grip compared to work boots, unless those boots are specially designed for walking roofs. Those boots are called cougar paws. If you don't already know what they are, I would encourage you to get a pair. They have a soft rubber bottom that's removable, so you can replace it when it wears down. But it's night and day walking a roof in cougar paw boots rather than sneakers, whatever the best thing that anybody's recommended to me of, I can walk a roof in this. I've walked a 10 pitch in a pair of Asics. That's fine, but cougar paws are going to be your better option for most things. And then having a rope harness, cushion. If you don't know what that is, you can talk. Well, you can ask me towards the end, and we'll talk about that. So again, we're gonna skip these videos. They don't do so well, but what I can tell you is those are concrete tiles that he's walking on. The lowest third of that material, that exposure, is what they call the headlap. And there's going to be more layers there than there is out in the field area in that middle third of that roofing material. And so there ends up being a bit of a cavity in that middle area. And so when you step on a hard material like this, especially cedar shakes, but concrete tiles also, clay tiles, I mean, clay tiles are very, very difficult to navigate without breaking. So use common sense. But the concrete tiles that he's walking on, you would think, man, concrete, that's what the sidewalk's made out of, so I should be fine. If you don't walk on that lower third, that headlap, as you walk, you're going to hear a crack. And that sweet, easy to walk on concrete tile now becomes a surfboard to take you right off the roof. So that's basically what he's communicating is how do you walk on these roofs? You need to walk on the headlaps if you're even going to walk up there. You know, the thickness of a cedar shake roof is a huge thing to take into consideration if you're considering walking on a cedar shake roof. You'd not want to walk on a shingle. You could walk on a shake, but the principle applies there as well. Walking on the headlaps is going to avoid breaking that material. And feel free, rifle off questions, you guys. And if you're going to ask questions, just make sure it's like a Q&A thing and not necessarily just popped in the chat, unless AJ would say differently. So let's talk about types of ladders. Okay, so you've got extension ladders, and we'll talk about some of the other types. That's an A-frame ladder, but it's kind of a hybrid ladder over there on the right. And this is the ladder that I would probably recommend that everybody get, because a lot of us probably want a good fold-up ladder to bring into the house if we want to, you know, if they don't have the attic stairs, if you've got to push that access port out and poke your head up through the attic that way or climb up into the attic that way, these fold-up ladders are the best thing you can find. Now, I will say a lot of people will go, yeah, that's cool. That's still kind of an expensive ladder. In some instances, it's more expensive than its extension counterpart. So they go on Amazon and they find what's called a telescoping ladder. Now, God bless you if you use one. Every single little locking joint is a potential failure point. And so, again, every rung times 2. That's how many potential failure points you have on that ladder. They also say they're rated for 350 pounds, and I don't trust that. I mean, I'm sure that it's true, like it's not going to break maybe, but it's very flexy, and I just personally don't like it. I have a couple extension ladders that I use, and then the primary ladder that I use for most one-story homes is going to be that, you know, Little Giant or Werner or other brand of hybrid fold-up ladder that sort of locks as an A-frame, and then you can unlock it and bring it out just like an extension ladder. And remember the 4-to-1 rule, right? So for every 1 unit of run, or sorry, for every 4 units of rise, you'll have 1 unit of run. So for every 4 feet up, you should be 1 foot away. And that's not from the height of the ladder, it is to the top of, or the base of the access point. So in this instance where you can see the ladder is leaning up against that gutter, the units that you're measuring in height are up to where that ladder leans up against that house, not necessarily to the top of the ladder. And you should be 1 foot away from a house for every 4 feet up that access point is. So again, if it's 12 feet up, you need to be at least 3 feet away. And that's going to get you in a good middle ground, because some people, like myself, I don't trust the bend of the ladder, maybe the feet kicking out on the bottom. That's just always been a thing of mine. So I set it up, you know, a little bit more straight up and down than the next guy might. And some people, when they're just getting comfortable using ladders, they really want to lean it with, you know, maybe 2 units per every 4 unit up. And it's such a shallow pitch that you put a ton of pressure on that ladder, and it's just not designed to handle that, especially when it's an extension ladder and it's extended all the way out. You're going to feel a flex. And if you have an aluminum ladder versus a fiberglass ladder. That fiberglass ladder is, not going to tell you before it breaks. So we'll go to the next one. So, sorry, and I will answer questions at the appropriate time, but I will answer Louise now that for securing your ladder to the gutter, which is a great idea. If they don't have a gutter, there's not much doing it. I personally use a husky strap. It's called a hang all. It's really designed for like hanging your framing gun off of a stud or something, but I remove the carabiner that they have on there and I just use it's basically a long Velcro strap, and I will sometimes use that carabiner and strap it around my ladder and hook it to one of the gutter spikes or the gutter clips. But that's just my personal favorite. I mean, a lot of people use bungee cords. You just have to remember with a bungee cord, the goal of tying off your ladder is twofold. One, it stops your ladder from blowing off the roof when there's a high wind. But two, if you end up taking a bit of a slide for yourself because it's a slick shingle, you want to be able to slide down to that ladder within reason and not have it stretch off the gutter with the bungee cord, because then you're going to fall in between the ladder and the house, and that's no fun. No fun. So I would recommend some kind of a Velcro strap or something like that, something that has a bit more solidness to it. One thing that I carried around for years was a 2 foot section of 12-2 wire. That's a great thing to just, again, zip up one side over to a gutter spike and go from there. So that one's for free. We'll keep pressing on. Oh, let me just talk about the types of step ladders first. Sorry, I'm kind of breezing by my notes. But the step ladder, like we said, is the workhorse of home inspections. You usually carry a 6 foot step ladder for attic access, 8 foot step ladder for exterior work, like looking at soffits and fascia. And then you've got your extension ladders, which is that one over there on the left. I guess I'm sort of taking it for granted that everybody knows the terminology for what these are called, but that's an extension ladder on the left. That's, again, I call it a hybrid ladder on the right, but it's in its current configuration, it's a step ladder. And then you've got a single ladder, which is basically half of an extension ladder. It's a non-self-supporting ladder that's not adjustable in length, and it only has one section. So technically, you could pull that extension ladder apart and have two single ladders. And the one that I keep calling a hybrid is technically called a multi-position ladder. It's a versatile ladder, like the Little Giant brand, like we mentioned. You can use them as step ladders, extension ladders, stairway ladders, scaffolding, and they're popular because it serves so many purposes. An attic ladder is another type of ladder. You can some people carry like a very compact, lightweight folding ladder, especially for attic access. When we mentioned the telescoping ladder that I am vehemently against, but if you choose to get one, I understand the price point on Amazon is probably $90 for that ladder. So if you want to risk it, don't get one that goes 2 stories. Just use it for attic access and things like that. I would use it to access an attic space, frankly, because it's very easy to carry. Okay, so some basic rules regarding ladder placement. You want to make sure the ladder is dry before you use it for hopefully obvious reasons. You don't want your feet to slip. Um, Best case scenario, you scrape your shin and it's still no fun. Worst case is the worst case. Remember to use that 4-to-1 rule for extension ladders, right? 4 feet of distance between the ground and the upper point of contact. Move the base of the ladder out 1 foot per 4 feet. Always wear slip resistant shoes, such as shoes with rubber soles. And those cougar paws do have a nice squishy rubber sole that will grab to the ladder rungs very well. Face the ladder while you're climbing up and down and keep your body centered. You can gauge your position by your belt buckle if you wear a belt. If your buckle passes beyond either rail, you're overreaching and at risk for falling. And specifically, what that's talking about is if you happen to see some kind of an anomaly or something on the gutter that you're trying to reach over and get a good picture of, if your belt buckle is out towards or past one of the one of the ladder rails, you're really asking for trouble having that ladder slide away on you and end up in a bad situation. So try to move the ladder if need be, but don't, try to stay squared up with that ladder and go straight up and down. And maintain 3 points of contact at all times, which is a big thing. You should have 2 feet in one hand or 2 hands and 1 foot on the ladder at all times. Whenever possible, it's best to use 2 people to carry and set up a ladder, depending on what ladder you use. A 40-foot ladder is something I'm able to use, but because of technique and strength and things like that, and I've been doing it for a long time, but some of those longer 32, 36, 40-foot ladders, they can be a bit cumbersome. So it's good to have a second person to help you there to set it up. Um, it may not be practical, but it is best practice. It becomes especially important to ensure the ladder chosen for use is not too heavy or difficult to move, that it's properly rated. If you don't already know, Werner has a color code system for the tips on the ladder. So the yellow or the red, one of those is the lightest. And so it's going to be the cheapest, but it may also not carry your weight because I think one of them is only rated for like 175 pounds. I always try to use one that's rated for more than me because I like things to be secure. So the green tip ladder is I think 225. The blue tip ladder is 250 pounds, I think. So take a look. If you find a deal on a ladder online, they don't come up often because they're highly sought after because ladders can be expensive. But the good thing to do is to check those Facebook Marketplace and Craigslist and all these other areas where you can get used items. Check for an extension ladder, but just remember if somebody's selling you a ladder for $90, there's a couple things to pay attention to. The first of which being what color are the tips if it's a Werner extension ladder, because if they're selling you a yellow tip ladder, they didn't get it for much more than what they're selling it to you for, and it's not a good deal because it may not carry you. And then other things to pay attention to are just the condition of the rope. And then a lot of times people drop ladders back and forth and there's bends to them. So, just use caution if you're buying a used ladder. I'd always recommend buying new, but I've been there too when you're early in your inspection career and you just haven't built up the capital to make those purchases yet. So ladders are not safe. I know that sounds crazy just to make a blanket statement like that, but the reality is they're the least safe thing that you can do. So I don't fall off of ladders, but that's because I use very good technique when I'm accessing ladders. So it says ladders are not safe, but it also, your wisdom and your ability to apply the principles you're learning today will really determine whether or not ladders are safe. It's kind of like saying guns are not safe. When misused, they absolutely are not, but when properly handled, they can be. So misuse or mistakes can result in death. Please keep all the ladders and tools at least 10 feet away from live power lines. Again, as many things as they mentioned for safety. I've been doing this long enough that I know stories for pretty much every safety precaution. I know somebody that, hit the electrical line and then got kind of blown off their ladder and broke their ankle. So these are all real things. They're not just in here just for liability's sake. It's legit. Set the ladder on firm level ground. Use ladder levelers on uneven ground. A lot of extension ladders have those, and the hybrid ladders have those as well. Don't use ladders that are or ever were damaged or broken. When setting it up, be sure to secure the ladder by tying it down using slip-resistant feet and by having someone hold it at the base for you. Keep the area around the top and bottom of a ladder clear. In passageways, doorways, and where there's traffic and other activities, try to secure the ladder or limit access to the immediate area while you're working. And there are little cones or signs that people like to put out, and I think that's wise. I think you can, do that without spending too much money on it. But just making any bypassers aware, hey, there's someone working on a ladder here. Just look up from your phone for a second and don't knock my ladder down, please. When using a step ladder, remember that all 4 of its legs must be on solid level ground. The spreaders must be fully open and locked. Step ladders should not be climbed and when closed and leaning against a wall. So they're basically saying if it's a step ladder, you can't use it like an extension ladder. It's not supposed to be used like that. When using an extension ladder, use the 4-to-1 rule. Some ladders used by inspectors are a hybrid of step and extension ladders. Whatever mode that ladder is in, the proper setup and safety guidelines should be followed. So again, if you're going to buy one of these hybrid ladders, the main thing is there's usually 2 locks at the hinge point, and when you open it up at first, both of those locks should pop into place and you can use it as a step ladder. If you're extending it at all, there's a lock on either side of the rung. Make sure those locks are in place on the side of the rung. And then when you open it back up, you've got to disengage those locks, unfold that up, and those two locks on the hinge point should lock back in. And if they don't, you could run into some trouble. So make sure you use ladder safety. If you have to step around a ladder because of the rungs, because technically, as shown in this example, 3 feet or 3 rungs, the rungs are, I think the top rung is 6 inches, and then every in between rung is a full foot, and then the bottom rung is 6 inches. So those normal rungs, you should have 3 rungs above the ladder. Now, technically, in this illustration, this inspector only has 2 rungs above the access point. That is technically not correct. I would prefer it how she has it, but you know, 3 rungs, 3 feet is what they want to see. And when it is 3 feet above that access point, you do kind of have to walk around it a little bit. So if you have to step around it, there should be a grab rail attached to the building to help you. I think that is only in the instance of like a commercial building, but it's part of the notes. And again, while you're on the ladder, always face the ladder and consider anchoring the top of the ladder. To Luis's point, asking what we use to anchor that off. If there's not a gutter, there's usually not a great way to anchor that. Now, if it was a scenario where you were actually performing work on your own home and you wanted to do this, you can use a strap, lift that lowest course of shingles, and put a nail in with the strap. Put the strap around the rung of the ladder, put the end of the strap up to the plywood, and you can sink a nail in there. But I certainly would never recommend that if you're performing an inspection on someone else's house. The reality is there are such things as difficult access points. And so when you're on a asphalt shingled roof and there's no gutter, there's not really a whole lot of good places to tie off to. So one thing I usually recommend is to try to, if there is one, set up in a valley where at least you've got security in one direction. If the ladder's trying to blow into the other gutter, it's not going to fall down, but there is no 100% success rate there either. So from the ladder, think safety first. Climb ladders that are rated for your weight, like we talked about. Ensure the ladder is properly leveled and on solid ground. Now, you do what you want on that. I prefer to set up in grass just because if I happen to fall off my ladder, I'd rather fall on grass than concrete. But you want to be on some solid ground that's very level. You don't want to be, if there's been raining for 3 days, cats and dogs, you don't want to set up in the grass because then one of the feet might sink in while you're trying to climb up, and that's not exactly solid ground. So dry dirt that has grass on it, good for me. Doesn't mean I never set up on asphalt or concrete, but I like to avoid it wherever I can. Make sure that the ladder's at the correct angle to the wall, the 4-on-1 rule. Pay attention to what the ladder is leaning against, as it's easy to mark siding or damage guttering if you're not careful. One point I like to make to that end is if you do walk up to a house and you see that a gutter is already dented or scratched, take a picture of it before you set your ladder up. That way, if you do set your ladder up and you're successful in not scratching or denting the gutter, then they're going to know that you got set up. And when you take your exterior pictures, if your ladder's already set up, you can see in the report where your ladder's set up. And they might think, well, your ladder was the last guy who set a ladder here, and I see a scratch now. Well, usually after an inspection or things like that is when people are going to be looking at things that they don't normally look at. Consider using electrician's ladders and steps that are made of non-conductive fiberglass that will protect you from shocks. Electricians use fiberglass ladders because it doesn't conduct electricity. That's good in case you want to protect yourself from hitting a power line. I don't like them because they're a lot heavier. And again, their failure mode is a little less predictable than aluminum. Properly stage the ladder according to standards. Grasp the horizontal ladder rungs and not the vertical rails. You can slip down the vertical rails. A lot of times they'll have little nicks on them. You can really open your hand up that way. It's not nice. So try to walk grabbing those horizontal rungs, not the vertical rails. Use the horizontal power hand grip, grasp rather than simply making contact, and distribute your weight among 3 or 4 locations. Here are several inspection tips when inspecting the roof covering material during a home inspection. Describe and report on the type of roof covering material. Describe and report on the visible condition of the roof covering. Visually inspect and report on the observed flashings. Check out the roof drainage, gutters, and downspout systems and components. Check for any overhanging tree branches that may have an adverse effect on the roof covering. Inspect the chimney system. That's a big one on roofs. And really, inspect all roof penetrations and report on any indications of observed defects at the underlying roof structure. So, a big thing is you want to sort of think about a roof in a couple general categories. You've got your roof covering material, which we'll call the field area, and then you've got roof appurtenances or protrusions or components, whatever you want to call them. But essentially, it is a fancy hole in the roof, right? So you've got a vent that needs to make its way out of the roof. They're going to cut a hole in the plywood, cut a hole in the underlayment, cut a hole in the shingles, and there's going to be a flashing that comes through that, and you install it as directed. So the field area of the roof is very rarely the issue. The roof appurtenances, flashings, step flashing, roof to wall transitions, anytime something changes direction, that's usually an area that you want to hone in on. So I wouldn't spend so much time combing through the field area of the roof and seeing if, the exposure is a quarter of an inch different from one shingle to the next. I get it. There are indications of poor workmanship that can lead to other discoveries, but you want to spend as little time as you have to get all the information that you're there to get. So definitely hone in on flashings, roof appurtenances like heat vents, power vents, attic fans, box vents, turbine vents. There's many, many more skylights, solar panels. All these things are, if you have a very simple up and over roof, there's hardly anything coming out of there in terms of protrusions, and you just have an up and over gable roof that's shingled on both sides. That's a roof that's like very seldom going to have a serious issue. It's once you start adding in different facing slopes that meet in valleys, you have, a lot of appurtenances. People want solar panels, and I've seen the solar water heaters and skylights. Skylights are, usually a nightmare. So those are the areas that you really want to hone in on and see, do I see any serious workmanship issues in these areas? Do I see anything breaking down, deteriorating? One thing we'll touch on in a little while is, the pipe boots or pipe vents, depending on what people call them. They are only designed by nature to last, I'd say, 5 to 7 years. Now, do they last 20 sometimes? All the time, no problem. But by design, the manufacturer of that pipe boot, unless it's a specialty pipe boot like a perma boot or a bullet boot, there's a lot of different types of pipe boots that they're now manufacturing to last the life of the roof. But your classic black plastic pipe boot, it's an ABS plastic, and it's got a neoprene sleeve around it where it meets up with the pipe. It's not designed to last more than 5 to 7 years. And so it should be changed several times throughout the course of the lifespan of the roof. So if you're looking at a pipe boot that's very old and it's a 20-year roof and it seems like that pipe boot is from the original roof install, that could potentially be a problem in short order if it's not already. So check and report on any observed indications of major defects related to the roof covering system, components that may be seen from accessible areas of the attic under the roof, including signs of sheathing problems, indications of prior or active moisture intrusion, or damaged structural components such as cracked rafters and damaged or modified roof trusses. That's a huge one. That's a big deal. If anybody modifies a roof truss, sorry, my throat's been dry throughout this, but if you don't know the difference between a rafter and a truss, usually a rafter just extends from the top down to the outer wall without any members in between other than probably a member up top. So if you see gusset plates nailing framing together, there's those shiny metal plates, you're probably looking at a truss. And if that's been modified in any way, they need to have a sign off from a structural engineer to do that. So that's a huge call out. If you see that there's a modified truss in an attic space, I would call it out immediately as a material defect. And what your verbiage should say in the report is, this is a material defect and needs immediate attention from needs to be evaluated immediately by a licensed professional structural engineer, unless documentation is provided that this change was made by someone with the sign off of a structural engineer. So let's keep going. So inspect the roof covering materials only. Not sure what this video was, but again, we're going to kind of be skipping through the videos. These are some good pictures of the roof covering material. So home inspectors should report on the roof covering or the roof covering materials that they observe during the home inspection. They should not report on the roof system, roofing, roof assembly, the components of which are not readily observable, right? Because a roofing system is comprised of not only the roof covering and not only the roof framing that you can see from the attic, but the underlayment, the presence of that underlayment, and in some instances, the decking. And if the deck has been decked over, like if you've got slat decking that you can see in the attic, but maybe that's been decked over with 7/16 OSB or something like that. So that's an important note to make is we're not going to report on it as the roof or the roof assembly because then you're claiming to have inspected every part of that roof assembly, and not every part of that roof assembly is always accessible. So the components of a roof system or assembly may include the roof deck, load-bearing components, trusses, underlayment, substrate, fasteners, thermal barrier, vapor retarder, insulation, ventilation, and the roofing covering. So you can't see the underlayment, you can't see the fasteners, you can't see the face of the decking. You can sometimes see the underside of the decking, but you certainly can't see the top side of that decking. The roof covering and roof covering materials are typically visible during a visual only home inspection. And as we know, home inspections are visual only inspections. Roof covering is a term specifically used and defined in the International Residential Code and building standards. Roof covering is the covering applied to the roof deck for weather resistance, fire classification, and or appearance. And since the roof covering is layered, not all of the roof covering material is visible during a home inspection. There are other terms that refer to the combination of components used together to form a complete assembly. A system is made up of smaller parts. An assembly is made up of smaller components. And most of the parts and components are not readily visible. They are beyond the scope of a home inspection. So the focus for the home inspector should be the roof covering material, right? For walls, we call it cladding, right? If you have siding, if you have whatever you've got on the side of the house to cover up the sheathing. So on the roof, you've got a covering material such as asphalt shingles, clay tile, concrete tile, built-up roofing, wood shingles and shakes, metal roof panels, and if it's a low-slope roof covering, might be TPO, might be EPDM, might be PVC, might be modified bitumen. For example, a built-up roof covering is a common roof covering for houses and buildings with relatively flat roofs, and it's made up of 2 or more layers of felt cemented together and surfaced with a cap sheet, mineral aggregate, smooth coating, or similar surfacing material. As a home inspector, you'll only be able to observe the top exposed roof layer. And if you've never seen how they do built-up roofs, they hot mop asphalt in a lot of instances over layers of felt paper. And so that asphalt becomes that water shedding part of that membrane. And so they layer it over 2, 3, 4 times. And so you've got this big, thick built-up roof. And maybe they painted over it. Like a lot of times they'll do a reflective coating on those. They'll do mineral surfacing. They'll do aggregate. You'll have things that you can't actually see the surface of the roof covering material. So you're only going to report on what you can actually physically see. Remember that just about everything, every component and system is limited and restricted in some way for the inspector during a visual only home inspection. So stick to inspecting and reporting on the roof covering. Now here's a fun one. Let's talk about roof slope and pitch because pitch is pretty much used interchangeably with slope. And a lot of times people say pitch and they mean slope and vice versa, right? So both pitch and slope indicate the incline of a roof expressed as a proportion of the vertical to the horizontal. So we're going to describe the roof slope and the roof pitch, and I encourage you to use the correct terminology. They're not the same thing. Slope affects how roof systems are installed, including dictating which type of roof covering material can be applied. Geometry. Okay. The illustration above shows a simple gable roof and the general relationship between rise, run, and span. Roof framing is a practical application of geometry, and roof slope is based largely on the properties of a right triangle. In roof framing, the base of the right triangle is called the run. The run is the distance from the outside of the wall's top plate to a point directly below the center of the ridge, you can see in this illustration. The vertical leg of the triangle is called the rise, which is the distance the roof raft or board extends upward above the wall's top plate. Slope is the incline of the roof expressed as the ratio of the vertical rise to the horizontal run, where the run is some portion of the span. This ratio is always expressed as inches per foot. So slope ratio, a roof that rises 4 inches for every 1 foot or 4 inches for every 12 inches of run is said to have a 4 in 12 slope. If the rise is 6 inches for every 12 inches of run, the roof slope is 6 in 12. The slope can be expressed numerically as a ratio. The slope ratio represents a certain amount of vertical rise for every 12 inches of horizontal run. For example, a 4 in 12 slope can be expressed as a ratio 4:12 or 4:12. A 6 in 12 slope is expressed as 6:12. A triangular symbol above the roof line in this architectural plan provides information on the roof slope. You can see right there, 8:12. The slope is expressed as a ratio and inches per foot. Pitch is the incline of the roof expressed as a fraction derived by dividing the rise by the span, where the roof span is the distance between the outside wall of one's top plate to another. So the pitch fraction, historically the word pitch meant the ratio between the ridge height to the entire span of the building, or the ratio between the rafter length to the building width. The ridge was typically in the middle of the span. This is no longer the case in a lot of modern building practices. The ridge can be placed pretty much anywhere in the span, from directly, a salt box house or something like that, from directly in the middle to either span endpoint. A roof that rises 8 feet over a 24-foot span is said to have a 1:3 pitch. If the rise was 4 feet over a 24-foot span, then the roof pitch is said to be 1:6. The pitch can be expressed numerically as a fraction. The pitch fraction is different from the slope. It represents a certain amount of vertical rise over the entire span. For example, given a roof with a rise of 4 feet and a span, the full span of 24 feet, the pitch is 1:6 pitch, which can be expressed as a fraction 1/6. A 12 to 24 pitch is expressed as 1:2, 1/2. The term pitch and slope, like I said before, often used interchangeably, and that's not correct. They don't mean the same thing. So slope is really the one that we're going to be honing in on as inspectors, and when we're describing it in layman's terms, we'd prefer to use the term slope. Using the illustration above and information we just learned about slope and pitch, we can see that a 212 slope can be expressed as a 112 pitch, assuming the span is twice the length of the run. If the roof slope is 412, the pitch for the 24-foot span is 1/6. If the pitch is 1/3, the slope is 812. Remember, slope is expressed as a ratio in inches per foot, and pitch is the fraction derived by dividing the rise by the entire span. So asphalt shingles. So if that wasn't clear to anybody, the moral of that story is you'd be better off when someone says it's an 8 pitch, they're really saying it's a slope of 8. So when someone asks you for the roof slope or the roof pitch, usually what they're asking is that inches of rise over, the ratio of inches to rise to inches of run. The run always being 12. So in that comparison, a 112 slope is a very flat roof or very close to flat roof. A 12 slope is a very steep roof. It's a 45-degree angle. So that, in the insurance world, they've got different categories of paying out for roofing crews to do different slopes. And usually between 2 and 7 is one category, 7 to 9 is another category, 9 to 12 is a whole other category, and then there's steep charges for anything above 12. So asphalt shingles. The slope of a roof affects the surface drainage of water and can determine the type of roof covering materials that should be installed. A lot of people kind of already know this because it's in building code, but asphalt shingles should be used only on roof slopes 212 or greater. Asphalt shingle roofs are designed to shed water, not meant to serve as a waterproof barrier. And this is one thing in my trainings that I'm really, really big on. Roofs are not waterproof, they are water resistant. So they are designed to shed water away, and they do that by being sloped. So there's a couple categories of roof coverings or roofs in general. A low slope roof or a flat roof, depending on who you're talking to, is 0 to 2. And then you've got 2 to 4 is a funny area in the code where you can use shingles if you want to, but you're required to take other measures like like the minimum measure that you would have to take to put shingles on anything from a 212 to 412. And in some instances, some jurisdictions are 2.512 to 412 to not include two as one of those things that you can shingle. You would have to do a double layer of underlayment, and you achieve that by instead of overlapping at 6 inches, you overlap at 18 inches, and the roll's 3 feet. So you end up overlapping two rolls, 18 inches and 18 inches, and you end up with a double layer application of underlayment. And so you can achieve it from 212 to 412, but it's not recommended really below 412. So most asphalt shingles may be used on 412 to 2112 using standard application methods. Asphalt shingles may be used on slopes from 212 to 3.912 or less than 412 if special low slope application procedures are followed, one of which is what I just told you about the underlayment. An inspector will usually find roll roofing materials installed on slope roofs that are sloped roofs that are less than 412. So the summary of this little section is that pitch and slope do not mean the same thing. Everybody loves the word pitch. The correct word to use is slope. You can use pitch if you're using it as a fraction, but again, remember that it's the span to the rise, not the run to the rise, the run being a 12-inch constant. If you were listening to my diatribe on that a minute ago, let me get rid of this laser pointer. There we go. That roof in the upper left-hand corner is a gable roof, and that's kind of your most simple, one of your most common roof styles. They're very easily identified. They have two slopes, and the ridge extends the length of the home. The lower level edges are often called the eaves, and the roof slope edges are called the gables or the rakes. We use both terms. And so if you can see that triangle up there where that window is, that's going to be a gable roof. If that wall extends up all the way to the peak of the roof, that's going to be a gable roof. A hip. There are two types of hip roofs, and both have four slopes. The basic hip roof has a level ridge, but the ridge doesn't extend all the way to the exterior walls. Instead, hip rafters slope diagonally to each corner. The hip rafters all meet to form a point at the peak of the roof. And you can see that in the middle one, there's a hip roof. Again, now you see that the walls are all rectangles and none of them follow the ridge all the way up to the top of the roof. There's a roof slope covering that area instead, and the structure of the framing is a bit different because your normal gable roof traditionally has, a ridge beam, rafters that run from the ridge beam down to the double top plate. On a hip roof, you've got hip rafters that run diagonally out to that corner, and then you have these other rafters. Mansard roofs were invented by the French when owners were taxed by the height of the building as measured to the roof eave. They're short, steep roofs installed around the perimeter of what's usually, but not always, a flat roof building. Some of these roofs can be nearly vertical, and this can cause installation problems, which will vary with different types of roof covering materials. And you heard us a minute ago say that asphalt shingled roofs can be, they have a lower limit, but they also have an upper limit in terms of normal roofing practices. When it goes above 2112, building code states that you need to hand seal all the roof shingles. And as you can imagine, access to the roofing system is very difficult. So flat roofs, or low slope roofs, as I call them, have very little slope. A typical slope would be 112. They can be less than that. I think they can't be any less than a quarter inch over 10 feet. Flat roofs may drain over roof edges or through scuppers installed in the parapet wall around the perimeter. Flat roofs are low slope roofs. Low slope and steep slope roofs have different requirements. And that is another terminology picadillo, I guess I have, when it comes to people describing roofing materials as commercial versus residential roofing materials. That terminology is not correct. The correct terminology is low slope roofing material, steep slope roofing material, and steep slope is defined as anything over 212. It's not steep to walk on, but it's defined in the roofing industry as a steep roof application rather than a low slope application. And a low slope could be just about nearly flat, but that's how it's defined. I'll move on. So shed roofs, those are roofs that have one slope because shed roofs are often used for additions. One potential problem area is along the upper edge of the shed roof where it ties in to the wall of the original home. You can see that in that lower right-hand corner is a roof to wall flashing, and right there is even maybe a little bit easier than sometimes those roofs run in where the sidewall is. But even still, you very often have problems at that flashing where a shed roof is running into the wall of a main structure. Gambrel roofs are usually associated with barns, but they're certainly not uncommon on homes. They have two slopes, each of which changes the slope or slant in a convex manner. Again, convex being bumping out rather than concave, kind of diving in. The point at which the roof changes slope should have metal flashing. Bonnet roofs have a change of slope but are concave, the opposite of a gambrel. A butterfly roof, it's a style that's seen less often. I see it on a car wash pretty regularly driving in Charlotte. When you inspect a home with a butterfly roof, look closely at the ceiling and floor beneath that low point, because for obvious reasons, a lot of water is gonna pool up in that middle. The house in this photograph had recently sold, and the sellers had hired a contractor to install a new roof. The buyers moved in, it rained, and the roof leaked. The buyers had to hire both a different roofing contractor and a floor contractor. The roof wasn't likely to leak due to the design alone, so it's a well-known. Sorry, the roof wasn't likely to leak due to the design alone, so this well-known architect designed not one, but two penetrations into the low point. The only things lacking are an anchor and a bilge pump. Um, Looking for that roof now. Maybe on the next page. I think it's just talking about an example of a butterfly roof, but I don't see one in this example, so we'll move on. So, a clerestory. These roofs show roofs with clerestory windows. Although the term clerestory refers to the positioning of the windows, it also generally describes their position as incorporated into a shed roof. In other words, clerestory is commonly used to refer to the combination of roof and window. Clerestory windows should have adequate clearance between the sills and the roof below in areas with heavy snowfall. This home doesn't and is more likely to leak. They should also have proper sidewall flashing. So as you can see, the top left photo, the clerestory windows do not have adequate clearance from the surface of the roof up to the sill of the window. It's kind of sitting right down on the window, and doesn't seem like any of these really have adequate clearance from maybe that one with the TPO roof. That's a pretty good little drop down from the sill. Cupolas. Cupola, spelled Cupola. They're small structures built into the peak of a roof, often to provide light to the area below, and in some cases I've seen it to provide ventilation. The inspection concern is the roof framing supporting the cupola. Although the framing will typically be hidden behind interior wall covering materials, look for signs of movement such as cracking, and other vulnerable areas are head wall and sidewall flashing. And then you got conical roofs. You can see a couple of those, especially on that green roof there. I think you would describe the one down in the middle as conical, but they're often used to cover towers and are often very, very steep. The first photograph shows a conical roof that's actually a series of tapered flat roofs, creating a series of hips. I think that one is. It says flat roofs, but I guess that conical down in the middle does have kind of bows out to a flatter roof towards the edge. So installing conical roofs requires special roofing techniques to get shingles to lie flat, especially near the peak. Inspecting these steep roofs closely is difficult or impossible without special equipment. That's one of the primary uses of a drone, is to inspect areas like that. So you can get as close as you can using binoculars or to look for signs of leakage beneath these roofs. The good news is, because they're so steep, they don't often build up a lot of ice and snow, so they'll shed pretty well, but the installation issues can abound because of how difficult it is to roof those. So, inspection concerns include flashing at the round sidewalls in areas at which conical roofs intersect with roofs of other shapes. Specially shaped crickets or flashing may be needed to provide long-term protection against leakage. You can see that green looking roof, maybe a church or a library or something. I guess it could be residential. Well, there's a bike in the yard, so maybe it's residential. But behind that, you can't see it in this photo, but they definitely have a special shaped cricket to divert water away from just building up behind such a big conical roof intersecting with that main gable roof. So the debris buildup behind those conical roofs intersecting with the main roof structures can be pretty significant. That debris holds moisture against the roof and the flashing, which often corrodes the flashing more quickly than it would on the rest of the roof. So those areas are a weak point. And if you can't confirm the condition of the roofing on the back side of a conical roof, you need to disclaim it and recommend inspection by a qualified roofing contractor. So what they're saying here is that there's so often an issue behind a conical roof that if you physically can't see in any way, whether with binoculars, whether with the ladder at the roof eave, if you can't see behind that conical roof, then you really should recommend that a qualified professional go look at it. I like to get on all the roofs that I go to, so I'll usually see behind that. But, the use of a drone is also very good for seeing areas like that and getting up close. I'll bang on it over and over and over again, but the use of a drone is only as good as the user who has it in his hands. So, if you're not so hot with roof inspections and you're not very well educated on it, I wouldn't encourage you to go flying a drone around because you're going to be responsible for all of the information that you depict in your photos. And if you don't know what you're looking for, putting a bunch of roof photos is not good when you say the roof's okay when it's not okay, or calling out issues that are there that are actually not issues at all. So a contractor may need to hook a ladder over the ridge in order to get high enough on the roof to see the backside of that conical roof clearly. That's especially true when the roof is covered with fragile materials such as slate or tile. Dormers are projections built into the slope of a roof. Here you can see dormers with gable, hip, and shed roofs. So the dormers that we're looking at here is primarily that lower right-hand one is a gable roof with a dormer. That upper left-hand one with the clerestory windows, that is a dormer as well. It's very large, but it's also a dormer. It's essentially, a roof structure popping up out of another roof structure. Other combinations and styles you'll see the several styles combined on the home, as you can see with that conical roof and the gable roof next to it. And again, a gable roof is designed or defined as a roof with two roof slopes, but technically that intersecting gable is still a gable roof. It's intersecting a larger gable roof, and then you can have a gable roof structure coming out of the hip roof. It happens all the time. Sorry, I was getting distracted. What do you recommend to inspect an asbestos cement roof? I recommend a ladder and not getting on the asbestos roof, especially if you know it's asbestos. And I also recommend that you guys use the Q&A feature. So, roof sheathing and covering life expectancy. The life of a roof really depends on local weather conditions, and I can tell you that firsthand. I've inspected roofs, like I said, from Maine all the way down to Georgia and Alabama, and pretty much every state in between there, depending on how many there are. I've inspected 16 states along the eastern seaboard, and a roof that in North Carolina is 18 years old looks like a roof in Massachusetts that's 38 years old. It's just completely different when you have sun exposure, UV. Um, there's a lot of different things but the hot climates really degrade roofs a lot faster. They drastically reduce the shingle life if you're using asphalt shingles. And that's why in places like Florida, for reasons of wind and hurricanes, but also for life expectancy, you'll see a lot of clay tile roofs down in places like Florida, whereas Massachusetts, New York, you see a lot of shingled roofs. You see a lot of slate roofs too, but they're usually 100 years old. So home inspectors are required to identify and report defects observed during the inspection, but are not required to determine the cause of damage or diagnose the underlying condition. According to NACHI.org SOP, A home inspector is not required to determine the age of construction or installation of any system, structure, or component of a building. The inspection image above is of missing shingles blown off by high winds. And that's the inspection image they're talking about is the one in the middle to the right. The one all the way up is tree rub, but the one in the middle is shingles that were blown off by high winds. Roofs in areas that experience severe weather, such as hail, tornadoes, and hurricanes, may also experience a shorter than normal lifespan overall, or may incur isolated damage that requires a repair in order to ensure the service life of the surrounding roofing materials. All roof coverings, regardless of materials, are susceptible to additional variables such as weather, impact damage, environmental conditions, orientation, ventilation, insulation, structural issues, and installation defects. And we'll talk briefly about how each of these variables affects a roof. So, we've all seen pictures on the news of homes in Tornado Alley, right? The geographic region that lies between Rocky Mountains and the Appalachian Mountains, with the roofs blown off. But it's not unusual to see weather damage in all areas of the United States, as well as in some various regions around the world. Sometimes severe weather damage will leave behind ripped shingles and dislodged tiles, affecting just one or two areas of a home's roof, but occasionally there can be more widespread damage that's a bit easier to spot. So again, you're not required to diagnose the causation of any particular damage if you're seeing something out of place, because again, if you're new to this, the, the the photos on the screen might look similar to you, but you know, a little bit closer examination shows you that the damage on the shingles on the very top, those are kind of like ripped at. It almost looks like they've been chewed on, and you can see a little clue with that tree branch up above. That is the wind blowing a overhanging branch back and forth and back and forth and back and forth over the surface of that roofing material over the course of a good number of years, which in most instances, I can't consult you on this, but in most instances, that would push it out of being something that's covered by insurance, because typically homeowners insurance covers sudden and accidental storm-related damage, not ongoing long-term damage from an overhanging tree branch. So the ones in the middle, those are in a pattern that looks like they've been dislodged by the wind. So it is a little bit different. So if you happen to see damage on a roof, you're not required to tell what the causation of that damage is or even opine about what the causation might have been. The best course of action would be to recommend a qualified roofing professional or, a roof specialist. A lot of the inspections that I've done are in lieu of them hiring a roofer, because a lot of roofing contractors, they want to do the work. And so if they're seeing damage like that, especially in the Southeast, I'll say, not necessarily in the Northeast as much, although it's very prevalent up there as well. If you call out a roofing contractor with some kind of storm damage, or something that looks like storm damage, they're going to want the homeowner to file a claim and try to get the whole roof replaced rather than just offering a simple fix for it. So, the inspection image, roof damage caused by an overhanging tree branch, like we said. Environmental conditions. This category of rapid deterioration on the roof covering can be attributed to airborne pollutants that are prevalent in industrial areas, as well as from the acidity of pine needles breaking down the roof surface. Chemicals definitely do different reactions with asphalt composition shingles. You can, we at our company, we perform desaturation tests to take the asphalt off of a shingle using mineral spirits. And there's a couple other chemicals that can accomplish that. So, nearby industrial facilities and things like that, if they're releasing chemicals into the air, that can degrade the roof surface. And the orientation of a roof can definitely have a significant influence on the long-term condition of the roof. A south-facing slope tends to show signs of overheating, particularly with asphalt shingles. And then north-facing roofs and those in the shade tend to have more algae and moss-induced problems, both of which could shorten the life of the roof covering. The sun is definitely more damaging than a lot of those organic growths. In fact, algae causes no damage to an asphalt shingle. It builds up on the surface, and it actually serves the purpose of holding the granules on, which are the primary UV reflecting component of the shingle, right? The water shedding medium is the asphalt, and the granules are there to protect the asphalt from breaking down from the sun. So if you have algae building up on the surface, don't let these soft wash guys tell you that you're preserving the life of your roof by washing the algae off. Now, moss, lichen, those things have a very, well, especially lichen has a very basic chemical compound in terms of, basic versus acidic. And it does eat away at the shingle itself. And when that lichen dies, it will create some damage to the roof. So, not all organic growth is good for the roof, but algae is really not a huge problem other than it's very unsightly. And if you're a man and you're married, get the soft wash if your wife wants to soft wash. Just wash the algae off and plan on replacing your roof a couple years earlier than you would have. Insulation. Inadequately insulated attics will also promote rapid failure of the roof covering due to issues such as ice damming in colder climates. And we can talk about ice damming later, but it's a function of insulation and these other things. And there's a certain amount of, you can't avoid certain parts of it. So that's why building codes in the, especially, north of the Mason-Dixon line are going to require that you use ice and water shield within 3 feet of the outside wall. So again, if you have a longer overhang, you're going to need to do 2 layers and those kinds of things. But in any case, structural issues, both the roof sheathing and framing can sometimes indicate structural issues revealed on the roof surface, such problems can be apparent as cracked shingles or tiles above a structural defect. More commonly, there will be a wavy look in the roof caused by thin roof sheathing that is overspanned. So again, there's a minimum thickness allowed for roof sheathing. In a lot of areas, it's 7/16 OSB, or I think 17/32 plywood or something like that. But if it's too thin and or overspanned, so the minimum span should be no more than 24 inches. But again, the plywood has a span rating on it, or whatever sheathing you're using. If it's plywood, if it's OSB, it will have a span rating on it, and it will tell you essentially this is how far in between supports it can be. And unless you're using 3/4 inch plywood up on a roof, which is not very common, most of those sheathings are not allowed to span more than 24 inches. And in some cases, 24 inches is even too much. And you'll start to see these waves in the roof decking, and it'll just look very unsightly. Installation defects. All roofing systems are only as good as the installer, and it's not uncommon to see all types of failure due to poor fastenings or other installation problems. Hopefully, we've all learned enough about what ladder safety is in this particular instance. And another thing I will say, just to circle back to that point, now Kenton's about to walk on a commercial roof, but in a residential application, one very hugely helpful thing where you don't need a gutter, and I forgot to mention this earlier, they have, in some of them are called bullhorns, some people will call them, but there's ladder standoffs, and there's ones that press, they're like an A shape, and they press into the side rungs of a ladder. Those require you to get the ladder a good bit over the eave in order to use, but they have rubber braces on them basically that lay on the shingles. The rubber is not very harmful to the shingles, and it makes it very secure to where it's not going to blow left and right. So rather than even putting your ladder on a gutter and trying to secure it with a bungee strap or anything like that, you can use these standoffs, and that's a good example of an instance where you're adding security and minimizing your liability for damaging someone's gutter. So another thing that we're required to look at is the roof drainage, right? The gutters and the downspouts. So unless the roof is sloped to drain over the roof's edge, there should be drainage installed for the roof system. Roof drains could be installed at the low points of the roof. Roofs should have some type of controlled method for disposing of water that collects, so it discharges to the ground surface several feet away from the foundation walls or into a drainage system. Gutters are sometimes not installed in areas that don't get heavy snow or much rain. While roof overhangs and porch roofs protect building walls from impinging rain, gutters serve to protect building walls and the foundation from roof water runoff. So again, if you don't have a gutter, water's running off the side of the roof. Well, again, it's shortest path to the ground is a vertical drop unless it's wind driven, and so it's going to just be eroding the ground around your foundation and possibly the foundation itself. Roof gutters, downspouts, and leaders or diverters form the initial components of a drainage system for the building and site. A proper design of gutters and downspouts for water-shedding sloped roof systems should be addressed during a roof inspection. Common problems with guttering are associated with installation and maintenance. Home inspectors can check if properly sized materials are being used, if guttering is appropriately sloped towards adequately sized downspouts, and if discharge is directed away from the building's foundation and perimeter. Discharge water at the building's inside corners should be avoided. Some local stormwater codes may require special filtration treatments of roof water runoff. Effective roof drainage is a must for two reasons. First, the roofing system needs to drain quickly so that large volumes of water are not trapped on the surface of the roof because, like we said, they're water resistant, not waterproof. Second, water runoff from the roof needs to be managed so that it's not being directed towards the foundation. Guttering systems, like everything else, have evolved greatly over the last couple hundred years, starting out as crude wooden troughs and ending with the vinyl and metal systems that we use today. And I still have seen wooden troughs be used that they paint liquid flashing inside of, and they're very, storybook homey. It's fair to say that most guttering systems are high maintenance. Homeowners with conventional uncovered gutters are required to regularly clean out vegetation and debris that get blown into them. Gutters often need to be refitted when severe weather detaches them from the fascia. Roofing gutters may be sloped down toward the downspout. It could be a slope of 1/16 inch per foot or a quarter inch per 5 to 10 feet. This is a general rule of thumb. It's not a building code. It's a best practice. The best practice I always heard was a quarter inch of drop for every 10 feet. It's a best practice that may be used by a home inspector when observing a gutter system. The point is that the gutter should be sloped towards the downspout. And a very low sloped angle may not allow great amount of water to move effectively, and a much greater slope cause the water to move too great a speed, potentially resulting in overflow at caps and corners. So again, it's not just a conservative thing, and it's not just aesthetic to have it pitched only a quarter inch for every 10 feet. It's a matter of you want it pitched so that the water runs down naturally because of gravity, but you don't want roller coaster with all that water piling onto an end cap where it's supposed to be fitting into, a 3-inch hole, a 4-inch hole. It's going to spill over the end cap of the gutters, and it's going to be without any point at that point. In terms of standards, home inspectors are not required to measure the amount of gutter slope. So to do it accurately would be time consuming. It would require a transit or water level. It would exceed InterNACHI standards of practice. So if you think that it doesn't look sloped correctly, one big indicator would be whether or not there's any standing water in a gutter that does not have a clogged downspout. But without a scope, you'd have a tough time knowing whether or not a downspout was clogged if it's not visually accessible at the time of your inspection. So in judging adequate slope, look for signs of standing water in portions of the gutter away from the downspout and eyeball the margin against the fascia. That's one good tip, is to see, look how much of fascia is exposed at one side of the gutter, and then it will slowly disappear towards the high side, right? It's not uncommon to see gutters installed too low on the fascia or to see roof coverings projecting too far over the gutters. In both cases, this may lead to water overshooting the gutters completely. So that's one of your main things. Is not even as often do I see gutters that are not pitched properly. It's gutters that are installed, if they go too low on the fascia, if you sort of project the angle of that roof. And one way to illustrate that would be if you have a level or any kind of a long straight thing, even a tape measure will function. If you run off the end of the roof, the end, whatever material, whatever thing you're using, like I like to use a level or something like that, where I can slide it down and it should hit the inside of the gutter because that represents the water and where the water is going to be going. If it's installed so low on the fascia that I run something down the slope and it overshoots the lip of the gutter, well, then that's what the water is going to do when it's going at enough speed. Now, that's not going to happen in a very light trickle because the water is just slowly running off the roof. But once you get a really severe storm, now the water is going to be running and just overshooting the gutter completely, eroding the ground underneath it and possibly causing a foundation issue. So typical gutter systems hold up better when the brackets are spiked or screwed through the fascia and into the rafter tails, not just into the 3/4 inch fascia board. So we'll look at some various types of gutters and their common weaknesses, as well as materials, installation, and maintenance. If you haven't noticed already, that top left corner is a vinyl gutter with vinyl gutter brackets. And then there you have your typical seamless aluminum gutter in this middle picture in the lower right picture. And those come sort of factory painted. Some people will paint over them, but those are some primary types. So, not all homes were designed to have gutters. In some areas of the United States, they're deemed unnecessary due to very low rainfall or heavy snow accumulation. Even in areas with higher rainfall, some homes were designed with a long eave overhang, such as much as 4 or 5 feet, to direct water away from the foundation. However, it does not always have the desired effect. Yankee gutters. These are little more than diverters directing water away from specific areas of the structure, particularly over doorways and entrances. They don't have one shown here, but it'll just basically be an L-shaped piece of metal that's installed, and you'll usually see that that's going to be installed right over where there's a doorway or wherever there's a window and things like that. Yankee guttering was the earliest form of water management. In some very old homes, there are still planks held in place by wooden blocks. Normally, they were lined with tar to both protect the gutter and to seal it to the roof. The modern version of the Yankee gutter is a metal type that is seen on new construction directly over entryways. Wooden guttering is still fairly common. It was being installed as recently as the 1930s. And again, if you live in a northern climate, I've seen a lot of wooden guttering personally. They usually don't leave it as sealed wood. They'll usually line it with some kind of it used to be pitch, but now it's some kind of asphaltic compound that's like a liquid flashing. Originally, it consisted little more than wooden troughs, but these were later milled out of closed grain timber and are very similar in profile to modern metal and vinyl systems. In many cases, they were lined with either tar or metal, such as lead, copper, or aluminum. I have seen that in a high-end scenario where they pinned, copper that was easy to bend inside of that gutter system. It was gorgeous. Cornice or gully guttering. Cornice or gully guttering is an integral part of the roof system. Typically, the guttering was laid down with the roof framing and sheathing and then covered up with metal or rolled roofing running up under the roof covering. The downspouts are often hidden inside posts or pillars to mask their presence. When these fail or when the downspouts become blocked, they can wreak havoc on the roof structure. Most of these systems have now been built over and normal fascia applied guttering has been installed. And I'm glad that that was in the notes because one thing I was going to say is we're going to talk about in all of these courses all kinds of different stuff, right? But it's not going to represent 80 to 90% of what you're actually going to see on a home. You can run into it, but you're not very often going to see cornice or gully guttering. It's almost been completely eradicated. I'd be very surprised. I've been inspecting a long time. I don't want to keep saying that, but I've never run into gully guttering, and I doubt you will either. But if you do, take a picture of it and put it on the InterNACHI forum. I'm sure the guys will get a kick out of it. Metal and vinyl guttering. The two biggest problems with steel guttering are rust, if not properly maintained, and the potential for leaks in joints and downspout connections. Steel guttering comes in shorter lengths, so there tend to be many joints in the system, not just at the corners. So again, if you're buying steel gutters that are 10-foot runs, they'll have galvanized steel gutters, and you'll usually get rust and holes in the bottom of them. It looks like that that center bottom photo is probably steel because I feel like I'm seeing some rust there, but I've been wrong before. The most common method of connecting the components is using aluminum pop rivets. Sorry, so aluminum guttering is usually formed from a roll sheet of aluminum. If you've never seen it happen, that K-style gutter is what they call it, where you have that high flat back and then it comes down in sort of a decorative lip out on the edge. That's called a K-style gutter, and there is a huge roll of coated, factory painted aluminum. And the most common colors being brown or white, but you can get them in almond or green probably if you want to. But those come in a flat sheet that's in a huge roll, and you mount it on a machine. You feed the end of the roll into the machine, and there is no really upper end there's no limit on what the run of gutter can be. I've seen a 120-foot run of seamless gutter. Now it's a booger to install, I imagine, but there's no seams in it, and it's much prettier. So a lot of more modern builds are going to have seamless aluminum gutters. That's probably your primary form of guttering in today's day and age. The big difference is whether or not they're using 5 or 6-inch gutter and whether or not they're using 2x3 or 3x4 downspouts. The vast preference that I've seen is to upgrade to a 3x4 downspout, even if you only have a 5-inch gutter, just because you want the capacity of what can flow out to be better. And there's really not a tremendous drawback to having an oversized downspout. So that aluminum guttering, it does come in 10-foot lengths. If you walk into Lowe's, you can get aluminum gutters at 10-foot lengths and they'll have seams. But it's usually on site with a roll of sheet aluminum, and that leads to fewer joints. And then, at the corners, inside corners and outside corners, you're still going to have connections and you want to evaluate those areas. So if you walk up to a modern build, and I say modern, could be 20 years old, but more modern than a house that was built in the 60s with gutters from the 60s. If you walk up to a modern building, you see that it has seamless aluminum gutters. Great news, there probably will not be a tremendous amount of leaks in the field area of those gutters. So your focus should be on the corners. See if the corners were sealed up correctly. See if the downspouts were lapped correctly, right? All of the bottom pieces should be tucked into the top pieces so that, did I say that correctly? Sorry. The top pieces should be tucked into the bottom pieces. So as it comes down, the water shouldn't be able to find a seam, if that makes sense to you. The most common method of connecting the components is using aluminum pop rivets, and in a lot of cases, just self-tapping coated screws. Those very frequently fail, either from impact, damage, or a building movement. Copper guttering in your area may be a lost art. It's not in mine. We've got copper gutters down here. My brother has copper gutters on his house. It may appear on high-end new construction and on quality restorations of older properties. What makes copper systems desirable is that all the joints are soldered, including those of the downspouts. That tends to make for a system with a long service life. And that's true. The seams on those systems, they actually have to heat them up with a torch and solder them. Now, one thing that you may look for on a copper system is whether or not they overheated the copper and damaged it using that torch. Because, like I said, it may be a lost art, but usually those copper systems are going to last a long time. The price reflects that. Common gutter inspection issues, regardless of material or style, all gutters tend to exhibit common problems and should be inspected primarily the same way. The inspection image above shows a common defect of a disconnected downspout. Again, that center bottom image shows a disconnected downspout. So here's the what to look for list when checking the gutter system. Does the gutter slope downward towards the downspout, right? We talked about that. There's some visual indicators that you can check to see, does it seem like there's an appropriate slope on there? Knowing that there is no technical building standard for that, but if you want to apply a common rule of thumb and say that it kind of violates your rule of thumb, that's fair enough. You can do that. Are there downspouts present? I have seen guttered homes where the downspouts have been, I don't know, thrown away for one reason or another or blown off the house. I don't know, but saw gutters everywhere, no downspouts. So at least they're limiting the water erosion to one area, I suppose, if you want to look at the bright side. Does it appear to have an adequate number of downspouts? That's a big one for all these cut-up roofs, and there's inside corners and outside corners. It's very difficult to pitch something that takes 4 turns all the way down to one end. So if there's a long run and then a bunch of turns, you want to see a downspout on one end of that and a downspout on the other side of that. Is the guttering securely fastened to the building? And again, you can't always readily see whether or not it's fastened to the rafter tails. If there's a way for you to see that, I would recommend calling that out, because if it's just screwed through trim's 3/4 inch board, and when you've punctured it with a fastener, now you've kind of broken the finish of the board. And if water's sneaking in behind that gutter, you're going to rot out that board, which might be true anyway, but if the screw penetrates all the way into the rafter tail, that gutter's still going to be secure. Are there any brackets missing? Are there any gutter spikes backing out? Can you see signs of leaking from the joints? Right? You're going to see water sort of pooling up on the underside, and then there's going to leave stains on the bottom of the gutters. So you can see near the seams if there's any leaking going on there. Are the gutters blocked by any debris or even rooted vegetation? I can't tell you how many times I've walked up and seen little trees growing in the gutters. That's deferred maintenance, and that's something that I'd want to call out, because that is going to stop water from flowing freely into the gutters, and usually it backs up, runs over the back before it runs over the front in some instances, because you've got shingles there and underlayment that will kind of wick that water up and rot out the decking right at that edge. So take a good look at the bottom of the gutters. The contents will typically point to the problems with the roof covering. For example, if there's large amounts of asphalt aggregate in the gutter, that could be a sign that the roof covering is nearing the end of its service life. Be careful, because brand new installation can also result in some aggregate in the gutter. The bottom right inspection shows a lot of granular material inside the gutter that indicates the age of the roof and the condition of the roof covering material. So you can see the bottom right photo. Now, again, there's two times where there's going to be, well, I'll say three times where there's going to be a lot of surface aggregate from an asphalt composition shingle winding up in the gutter. The first is when the roof is first installed. There's granules on the shingles that they call hitchhikers that are basically not bonded to the shingle, but they're just sort of stuck in between other granules. And those kind of pop loose first. And so you have a lot of granule loss right at the time of installation. So there's going to be, and now a lot of roofing companies will run a hose or even a leaf blower to get some of that out of there. But when the roof is brand new, you're going to have a lot of aggregate in there. And then if you don't already know this, roofs tend to break down and the breakdown accelerates as the roof gets older. And I don't just mean that there's more breakdown when something's older. Of course, that makes sense because if it breaks down every 5 years, every 10 years, by the time it's 20 years old, it's obviously more broken down than it was when it was 5 years old. But specifically, what I'm referring to is that the amount of breakdown of a roofing material from 0 to 5 years is much, much less than the 20 to 25 year mark. So it's like this, a reverse snowball effect, if you will. As the roof gets older, it degrades faster. So you'll see a lot of surface aggregate in an older roof. And then if there was a recent hailstorm, those even sub-severe hail that's very small can dislodge granules from the roof. Not any more than rain or walking on the roof would dislodge some granules. So it's not necessarily damage, but in an instance of a heavy rain or a hailstorm, you can have excess granules found in that gutter. Downspouts and terminations. Downspout estimation. There's a very general rule of estimation. Every square inch of downspout is capable of discharging drainage for 100 square feet of roof surface. What does that mean? It means a 2x3 gutter, which is your standard smaller, sorry, not gutter, downspout. Your standard smaller downspout is a 2x3. And again, it moves up to 3x4 from there. So a 2x3 inch downspout can handle 600 square feet of roof. And a 3x4 inch downspout can manage 1,200 square feet. For a 30x50 house with a gable roof at a 412 slope, quick method to calculate the square footage of the roof covering is 1,500 square foot footprint by a 1.054 slope factor or a slope multiplier. And you can look up a slope factor, ask Grok, ask Google, ask whoever you ask, but you can look up what the slope factor is, which is basically to say if you can get generally the two longest measurements of a house and pretend that it's a big rectangle, no matter what shape it is, you have a rough footprint, and then you apply the slope factor of the slope of the roof to that footprint, and that kind of tells you roughly how many square feet you have on the roofing system. So for, again, a 30x50 house with a 412 slope, you've got a 1,500 square foot footprint, and then a 1.054 slope factor results in 15.8 square roof, or 1,581 square feet. That assumes a simpler gable with, no hips and valleys, but again, it's all kind of rough math anyway. If there's typical rake overhangs and eave overhangs, say 12 to 18 inches, you'd add roughly 10 to 15% more material, bring you to around 17.5 to 18.5 squares of actual roofing material needed. So if a common 2x3 downspout can manage 600 square feet using our general rule of estimation, then we need at least 3 downspouts to serve that roof, right? So if that makes sense, 2x3, 6 square inches times 100, 600 square feet can that downspout handle. So they want you to estimate the size of the roof, and then there should be, if you're using 2x3 downspouts, you can manage 600 square feet of drainage for each downspout. And if it's a 3x4, you can manage 1,200 square feet. So that's just a rough rule of thumb. It's not something you need to put in there and say, building code says this or anything like that. It's a rough rule of thumb just to kind of give you a general idea. Does this roof have enough downspouts to get rid of the water that's coming off of that roof? Or during a heavy rainstorm, is it just kicking over the edge of the gutters? Most downspouts are made of the same material as the gutter system, so they tend to suffer from similar problems with a few twists, especially in the area of mechanical damage from proximity to high traffic areas. And one of those areas a lot of times is trash barrels. You know, the big trash bins that everybody puts their trash in outside. The lid is, flipped open and bangs the downspout, and you're kind of reducing the capacity of that downspout whenever you crush it. So inspect downspouts for the connections between the downspout and the gutter, proper attachment of the downspout to the structure. There needs to be some kind of a clamp. And you can see in that lower middle photo, there's that clamp going over the side. Now that's not my favorite way of discharging that, but they have, it looks like a French drain at the bottom of that. It kind of freaks me out with the being that close to the structure. But I digress. Look for impact damage from car doors, etc. Downspouts that terminate onto another roof surface. That will quickly erode the roof covering at the termination. And if it discharges laterally, you're opening yourself up to a can of worms because you're going to force water underneath shingles, and that will probably erode the fasteners and end up in a leak. Whether the termination is directing water away from the foundation, right? That's a huge one. And again, in that lower middle example, it looks like they have some kind of a drainage solution there, so I can't knock them. But if you look at that left one where the downspout extension is too short, that water is really not being diverted. It's being diverted technically away from the house, but it's not a long enough extension. So you're not following the grade of the land well enough to get the water actually away from the house. You're going to have disturbed soil near that foundation, and that is going to flow into that. And, we can get into hydrostatic pressure and all those things, but water away from house, please. That's all we need to know. Let's get the water away from the house. If for any reason you have a question about the roof drainage system where you're not sure if it looks like water is actually being diverted far enough away from the house, you're probably right. If it's raising a question to your inspector's eye and you're saying, I don't know if the water has an easy time getting out of here, it may not. Internal drainage. A lot of flat roofs have internal drainage where you'll see a drain on the roof with a little cage over top of it, and it'll drain down into a pipe that will discharge somewhere else. So make sure the roof slope has to be a 1/4 inch per foot at minimum in most instances. Check for poor flashing between the roof covering and the drain. Check the drains for blockage, right? Because all it is just a little plastic cage on top of the roof. If you get a couple leaves there, that's going to drastically reduce the amount of water that thing's able to handle, and you'll get pooling up on the roof, or ponding is what I would call it. The internal pipe system could fail due to pipe corrosion. That's not something you're going to be able to see, but especially in an instance where you've got interior water damage and you're right below one of these areas where whether it's a scupper or an actual roof drain, you're going to have a lot of problems with that system. They're very common to have problems in that system. And you can see in that example, you've got a roof transition from a sloped roof down to a low slope roof. Yeah, a flat roof in this instance. Looks like built up roof, tar and gravel, and you've got ponding on the roof. And anytime you don't shed water, you're going to run into some trouble. Inspecting roof slope and pitch. Again, go on InterNACHI, nachi.org, and see Ben explain that maybe better than I have here. But either way, just remember, slope is the word that we're looking for. Roof framing from the exterior. You can see the different types where you've got this a sagging ridge due to inadequate or missing rafter ties. So those rafter ties would be up in the top. They're a horizontal member that connects one rafter to the other and stops that load. And I don't know how many of you are framers or however many of you are engineers, but you got to think in terms of load path when it comes to these things. If you see a sagging ridge beam, then you should be thinking about the gravity load that's on that and kind of what would happen with the interior structure. And so if you see that, the next thought in your head should be, I'm going to make sure when I go in the attic to take a peek that I look and see if there's any collar ties or rafter ties or whatever you want to call them. In a structural ridge, you don't have that problem because you have a ridge beam that has support posts on either side of the house. And that really depends on the beam that you have in there and whether it can be spanned to that length. But you can see in that lower left image, you've got dips in the sheathing. Now, are those dips in the sheathing because the gravity load is too much for the type of structure that's there. It wasn't built properly, and now the rafters are bending under the load. Or, what's the space between the high points? Does it look like there's 2 feet where that roof is sagging? Well, now you're probably talking about an overspanned sheathing. And then that middle bottom is a cinder block building, concrete structure. And when that load comes down, that gravity load causes that ridge beam to sag. Well, they're rigid framing members, right? So if you've got a sag in a triangle in the middle, it's going to push the triangle out on either side. And so that's where you've got the bending rafters are causing outward thrust on that wall, and it's compromised the integrity of that structure to a significant degree. So again, we're not going to be walking on that roof. We're probably calling in a structural engineer to say, I think this needs further evaluation from a qualified engineering professional, because there's a serious problem here if that wall is caving out like that. Conventional roof framing. A home inspector should have an understanding of the two main basic roof structure systems. One is conventional roof framing and one is roof trusses. If you don't already know kind of what that is, a truss is an engineered system that's designed to be able to use smaller dimensional lumber in a configuration where the shapes that are built into the structure add strength to that those members otherwise wouldn't. So in the instance of a roof rafter, depending on the span, you're going to see a minimum of a 2x8, maybe a 2x10, even a 2x12. Those are going to be big, beefy pieces of lumber because they're designed to be spanned a certain length. With trusses, you're probably going to see it built out of 2x4s or 2x6s, and there's going to be a lot of shapes added in. And there's a million different types of trusses, but just know they're not pictured here. What we're looking at is conventional roof framing with rafters and ridge beams and those types of things. Your normal purlin system does it provides an extra mid-span roof support. So you've got purlin braces, and sometimes you'll see knee walls in those areas in the attics. Again, that's your traditional framing. That's a rafter system. The common rafters that rest on the outside walls in the bottom and connect to the ridge, those are called common rafters, highlighted in yellow on that top left area, right? It's running up to the ridge beam. It's going down to that outside wall. Rafters should be on opposite sides of the ridge, directly opposite each other. As you can imagine, you want that ridge beam not to be getting lateral pressure from either direction. So you want the rafters to fall right up against that ridge beam opposite one another, so they're sandwiching the ridge beam and not trying to deflect it. Sometimes rafters do have to be moved a little bit to accommodate components of other home systems. That illustration above on the right, top right, shows an offset rafter to accommodate a vent pipe. If you see that a lot of the rafters don't align, you might make a comment on this, but in existing homes, refrain from calling it a defect unless you see an indication of a major failure. In newer homes, many rafters which don't oppose may indicate poor quality framing. It's an indication that you should look carefully for other problems. And that's pretty much true for every little workmanship issue you see. I would, definitely be on the lookout for other issues when you see bad workmanship. Those rafter top cuts and then seat cuts. The seat cut is a lot of times called a bird's mouth cut, but the proper name is a seat cut. And you can see there, good versus bad. Hopefully your eye can catch if something's not flush, it's not good. Now, if it's out on a deck and something's not flush, it could have been flush when it was installed and the lumber was a little wet and it shrunk a little bit, and so there's a gap. But in this instance, you're usually using kiln-dried lumber for interior framing. It should be pre-dried when they install it, so you're not going to have a lot of shrinkage. It's just a matter of not seeing a flush lineup is just a bad cut. So take a look at that. Again, it's not something I would call out as some material defect. I would just say, look for other indications of bad workmanship that might have worse effects. You can see the seat cuts at the bottom, and that bad seat cut, it's not resting fully on the plate. The good seat cut is nice and flush. At the top of the illustration, the two cuts with the rafter boards at the top, where they meet the top plate, are displayed. The left is bad and the right is good. As you can see, the bad one just isn't landing flush, and so the full force is being reduced to one point load instead of being distributed throughout the width of that rafter. Inspecting the cuts of rafters where they rest on the top plate and the top ridge board is important for several reasons, all of which contribute to the overall safety, integrity, and longevity of a home. Right? If you're asking something to do its job incorrectly, then it's not going to be able to do it as long as if it was done correctly to begin with. We'll kind of keep moving here. So, a truss roof system, right? You can see cambered truss, double howe truss, flat truss, studio truss. A scissor truss is a pretty common one, a jack truss. These are all different truss type systems. What you can see is that there's a top cord, bottom cord, diagonal bracing, there's web members. The web members create those shapes that adds that strength. There's truss blocking to stop the trusses from racking back and forth, and then there's gusset plates. So if you're not sure if you're looking at rafters versus trusses, you can just make sure that there's gusset plates. Now, those ones in the middle bottom, that would have to be something that was signed off on by an engineer because those are wooden gusset plates and they're usually supposed to be metal, manufactured at a truss facility. Both the bottom middle and the bottom right just look like they're older systems that somebody added in lumber to create a truss system that I don't trust very much, frankly. That one's for free. So if you're not sure what you're looking at, look for the gusset plates. Look to see if there's metal plates attaching these different framing members. And the main thing for you guys, if you're looking in the attic and you see a truss system, look around at the other components. Look for electrical, look for HVAC, look for these other things because a lot of times those contractors have zero structural knowledge. They have zero code knowledge about structural members. All they know is their trade. And so it's just kind of this age-old thing that the guy comes in after the fact, whether it's the electrician or the plumber, he makes modifications to framing members to make his job easy without realizing that he's putting everything at risk because he just doesn't, again, hopefully, he just doesn't know what that compromise is that he's making by modifying those members. You cannot make any modification to a truss system without a sign-off by a licensed professional engineer. So they're engineered framing components. They're usually manufactured in some kind of a plant. You can have trusses on interior walls. The bottom cords of trusses should be fastened to the tops of interior non-load bearing walls with slotted clips rather than nails sunk flush, which will allow for some vertical movement of the trusses, right? If you have a nail just driving down into something, it's a smooth shank nail, framing nail. It has a tendency to back out with expansion and contraction. Movement is usually related to changes in the moisture content of the wood trusses. And again, expansion and contraction causes movement, and you end up with things pulling apart from one another if they're not fastened in correctly. Most roof trusses are designed to bear on the exterior walls only. So if you want an open floor plan, usually you're going to have to go with a truss system. And then there is such a thing as an engineered floor truss. Instead of using floor joists, you use floor trusses and you can have like a whole open floor plan basement off of like one beam supporting those floor trusses. So there's that. Truss case study. So this is a garage of a house. The neighbor told the home inspector that the roof of the garage next door had collapsed during a big snowstorm the previous year. During the home inspection of the roof system from inside the garage, it's easy to see that trusses have been altered. Plywood gussets, the wooden triangles there, were added at a connection that would typically have had metal truss plates installed. Right, so the picture above is of a truss plate. Truss plates are metal connector plates. They're also commonly referred to as gang nail plates. And even those gang nail plates, if you see them and they look banged in, they're supposed to be pressed with even pressure at a facility, not like somebody putting them together in his backyard and banging them with a hammer. Gusset plates, truss connector plates, metal plate connectors, or MPCs. Truss plates are thin galvanized steel plates with teeth that are pressed into the wood members on both sides to join truss components together. The teeth are punched through the plate and embedded into the wood under high pressure during the manufacturing process. In the rare instances which alterations involving plywood gussets have been approved by a structural engineer, gussets usually have backing for perimeter nailing installed, are glued with a special construction adhesive, and are heavily nailed with nails every 2 or 3 inches or so. You should see a lot of nails and glue squeezing out of the joints. As you see here in their images, that was not the case. This is clearly a modification made by somebody else. Well, looking over the wall, you'll notice that the hangers seem to be small for the load they're carrying, which is very true. The hangers turned out to be sized for a 2x4, which is small, far too small for the roof load they're carrying. There are fasteners with a total of 4 gold deck screws each. And that is very sketchy. The deck screws are a major defect because they're rated far below acceptable hanger nail strength. Remember that. Not all screws are created equal. Simpson has these, you know, Simpson makes all these connectors for different applications, and Simpson has their own screws to use for their own connectors because they're rated for a certain shear strength. These little gold screws, they look like interior screws. They're not, they don't seem to be a load-bearing thing. They're just not designed for that level of pressure because they're going to want to shear off. Roof panel sheathing, we won't go too crazy with this, but just know that there are panel ratings. There's rated structural sheathing, there's regular rated sheathing, and there's just common uses for these things. And usually when you see a certain type of sheathing, like 7/16 inch OSB is usually used for roof sheathing. There's a reason for that, right? So when you see these things, the span rating has a lot to do with this. Size for spacing, exposure 1, thickness 0.451 inches. You have all these things on the APA label, and you can look those things up if you're so fascinated to do so. But just know that there's a minimum lumber roof sheathing thickness, a minimum net thickness, and then there's the spacing for the rafters, the beams that they're installed on top of. So you're not going to see these APA ratings on the plywood more than likely, because usually they put those ratings up. But even if you see them in the attic, start with, is there a problem? And then go to, was the proper sheathing used for the application? The minimum thickness of lumber roof sheathing should conform to the table that you see there below. And then there are allowable spans for wood structural panels for roof sheathing. Other trim areas and issues, you got cornice returns. And as part of that cornice, you've got the cornice, the frieze, and the architrave. And then you've got a dental cornice with that dental molding that you can see. Again, it's dentil, TIL, but you can kind of notice it by its similarity to some gapped teeth, just as a help. It's a decorative thing. It typically consists of the fascia, soffit, and any trim moldings that create a finished transition between the roof and the building siding. It's an architectural feature. It not only provides visual appeal, but it protects the roof to wall connection from weather while allowing for attic ventilation through soffit vents. Roof framing fundamentals. We've kind of already talked about some of this stuff, but you've got your gable dormer ridge board. This is a gable that's being framed into, this is a gable dormer that's being framed into a gable roof. And so you can see you've got the gable dormer ridge board, common rafters, gable stud, the dormer double top plate, which is basically just the top of a little wall. It's very conventional framing. And so, again, I would encourage you to do your own research on framing and how a house is framed. My personal thing has always kind of been, if I can't picture how to deconstruct something in my head, I'm not going to be able to properly diagnose issues with those things. And so a house obviously starts with the foundation, and then some of those next things are going to be framing members and putting together the interior structure of the home. And then those last finishes are usually not of any real use to us unless you understand that sheathing does provide shear strength to the home and things like that. So I would just say take these courses and look at framing. Try to get an understanding of framing fundamentals so that you understand when something's failing, what might be going on behind the finish that I can see, right? Understanding roof framing like this really helps when you see deflection and these other things. It can only be so many issues. It's not like a total mystery. If you see deflection in the roof surface, you either have an overspanned sheathing or you have a structural problem with those rafters. So again, we talked about the truss roof system with the truss blocking, the gusset plates, your diagonal bracing, your web members. That bottom cord is the one that usually gets cut for electrical and things like that. And that bottom cord provides the strength of the whole system. If that bottom cord is mangled at all, then you're going to have a serious problem. Slope requirements in their relationship. Again, you've got steep roofing, low slope roofing. Steep roofing, 212, greater than 212 in a lot of instances, 2 to 412 with some caveats, but 412 plus, you're good to go. Asphalt shingled roofs require a double underlayment application between 212 and 412. Concrete clay tile roofs, 2.5, 12 up to 412, require a double underlayment application also. And again, I'll leave that up for a second. We're not going to go through all that, but again, the principle is that there are different slope requirements for different roof coverings. So when you're looking at a roof and you're going, well, it's less than 212, that's a problem. Well, that really depends on what kind of roof you're looking at. And so a good broad category to put those in and do some research on is low slope roofing materials versus steep slope application roof materials. Asphalt shingles and any other tiles. Again, think about the way that the material is installed. If you've got an impermeable membrane, it's fine if water sits there a little bit longer. But anything where there's a tile or a shingle or something modular where there's a bunch of fasteners installed and then lapped over, well, if you let water sit there, it's going to back up to where it gets to the fasteners and penetrates into the inside of the building envelope. So that's a problem. So anything where it's modular, you're putting pieces on and nailing them in and then lapping them on top of each other, that's not a waterproof system. That's not impermeable. It's a water resistant system that's designed to divert the water off the top of the roof. And then low slope roofing materials are designed to be impermeable. They're not designed to just have water or snow or ice just sit there forever, but they are designed to have the water run off a little bit more slowly, usually into some kind of a drainage system where there's internal draining or external draining, scuppers, all those types of things. Fastening and connections. So when you've got a rafter, that joist is toe-nailed into the top plate. The rafter is probably toe-nailed. While you're inspecting roof framing, you'll notice various fastening methods holding components together: nails, screws, metal connectors, hurricane tires, and the specific requirements for fastener spacing, size, and type are detailed in the International Residential Code. For example, the IRC specifies nail size and spacing for rafter to ridge connections, rafter to top plate connections, and collar tie installations. Verifying that every connection meets code specified fastening requirements is definitely beyond the scope of a typical home inspection. You can't reasonably count nails or verify that a 16 penny nail was used instead of a 10 penny nail without destructive testing. And we do a visual only, non-destructive inspection, right? So what you can do is identify obvious deficiencies, right? If there's a missing connector, same thing with a deck connection. If you're missing hurricane ties or you're missing joist hangers, you're going to call that out. So look for obvious issues. And if you're not sure if it's an issue, flag it now, research it when you get home, and don't send out the report until you're sure. Collar ties versus rafter ties. A rafter tie, sorry, I may have used these interchangeably earlier. I apologize. A collar tie is in the top third, and a rafter tie is in the bottom third. So a rafter tie is typically what you're going to be stepping on when you go into the attic. A collar tie is going to be up above your head that you can reach up and grab onto so you don't fall through the ceiling. King post truss versus a collar tie. King post is a central vertical post used to help support a beam from a truss apex above. King post trusses are subjected to compression and tension. As the load is applied downward, compression is increased at the post. Rafter boards and the ridge board are normally under compression while holding up or resisting a load. The exterior load-bearing walls are holding up a load and are therefore under compression. Collar tie. That's a tension tie placed in the upper third part of opposing gable rafters that's intended to resist separation of the rafter from the ridge beam during periods of unbalanced loads, such as those caused by wind uplift or snow. So tension forces and compression forces. And then you've got outward thrust. And again, This is just in your mind. It should be picturing what that load path is, right? So you've got a, a vertical load or, a gravity load, a dead load from just the weight of the roof falling down. And so then you've got tension with the middle, the rafter tie wanting to be pulled apart. And then you've got tension with the king post because it's actually under compression and tension, and then the outer walls are under compression from those vertical loads and the fact that they're pressed up against the ground underneath. And then you have outward thrust, right? Where a ceiling joist or rafter tie does not provide continuous ties across the structure like that of a cathedral ceiling. The ridge should be supported by a wall or ridge beam and supported on each end by a wall or column. The ridge beam must be capable of supporting the full load of the rafters. The ridge beam must be stiff enough to minimize the deflection from the rafter loads so that rafter thrust does not displace the walls. And again, as you can see, that load is going down, and because of the angle of the roof, if that load starts to sag up where the ridge is, it's going to push those outer walls out. And you can see that in the diagram on the left, outward thrust on walls. So that rafter tie really, if it's fastened to the rafters, helps reduce that outward thrust. And a structural ridge board needs to be installed for roofs with a slope less than 312. That helps the rafters not have the ability to pull apart from one another. Bottom chord of a truss. In a conventional roof truss, the bottom chord acts as a tension tie between exterior walls. Alterations to installed trusses are not permitted. Cutting any truss, particularly at the bottom chord, destroys the structural integrity of the truss. If the inspector finds that the chord of a truss has been cut, they should recommend that a structural engineer be consulted. The illustration above shows what an engineered repair to a cut truss cord might look like as seen from the attic space. Bending movement. A bending movement occurs when a force changes from a straight form into a curved or angular one. The illustration below, or this illustration in this slide, shows a collar tie with rafters on top conventionally framed walls. As the load is applied downward, the rafters go into a bending movement below the collar tie. This bending movement exerts outward thrust on the walls, forcing them out of plumb. Roof coverings. We can talk about roof measurements using squares. Roof surfaces are measured in squares. I used that term earlier. A square is 100 square feet. So when you have the total square footage, if you divide by 100, that's your squares. So if you have a 24,000 square foot roof, you have a 240 square roof. And you can see this inspector is performing what's known as a test square. And so when you hear that term in the context of a storm damage evaluation, the term square is not necessarily the shape. It does tend to be 10 feet by 10 feet, but that is just by matter of convenience. It could be a circle if you wanted it to be. It just has to measure 100 square feet, which is 1 square. So a test square for hail damage is a 100 square foot sample size that represents the rest of the roof facing that same direction. So it's a statistical average. So as you can see in that illustration, there's a 10 foot by 10 foot. If this inspector was doing a test square, he would be circling a representative number of however many damaged shingles he finds in that 10 foot by 10 foot test square. And then that would be extrapolated across any other slope that faces that same direction. So you need a test square on one front-facing roof slope, and then that would represent every other front-facing roof slope. All right, asphalt composition shingles. The primary layers, mineral granules are on the surface. The fiberglass base mat is really the structure, kind of like in concrete when you have rebar installed so that the concrete doesn't just break apart. That fiberglass mat is the rebar of the shingle. The water shedding medium of the shingle is asphalt. So the waterproof and weather-resistant asphalt impregnates and coats that fiberglass mat, and then the whole thing is covered in crushed ceramic granules that provide color and UV protection, right? That's pretty much all you need to know as far as that goes. So whatever the configuration of an asphalt composition shingle is, again, you've got your high profile like Presidential down at the bottom. You got a laminated one in the middle, and then you've got your 3-tab on top. All of those functionally are made the same way, where you've got a fiberglass base mat, you've got it impregnated and coated with layers of waterproof and weather-resistant asphalt and coated on the top with granules. And then there's other things like, the sealant strip and the nailing line, and there's other things. But the composition of the shingle is those layers. Asphalt shingle installation. Underlayment is required. Sometimes you use felt, but a lot of more modern roofs are being installed with synthetic felt, which is kind of an impermeable membrane that functions basically like a tarp. The application starts at the bottom of the roof as far as the shingles go. So you lay down your underlayment first. It's got to be overlapped. And then you start your shingle installation. Your shingle installation usually starts at the lower left corner or a lower corner, and you stair step install. Basically, you run a full shingle, 3/4 shingle, half, and then a quarter, and then you just run the shingles to the right of that in courses. You should pop a chalk line to make sure they're being installed straight. But you can see the fasteners per shingle, minimum of 4 per asphalt composition 3-tab shingle. You can see the locations of those. And then on a laminated shingle, they're calling it a strip shingle. I wouldn't normally use that terminology. It's an architectural, laminate, or dimensional shingle is really the common terms for that. And then you'll have fastener locations that are above the exposure of the shingle. You can have 4 in high wind areas. They're required to have 6. But you can kind of check with your local authority having jurisdiction to figure out which is which. But it's basically in certain high wind regions where they're requiring 6 nails for an asphalt shingle. And then you can see the flat built up roofing. You've got your insulation down below, your cover board on top of that, then your roof felt, and then you hot mop asphalt between the layers of the felt, and then you've got that gravel aggregate on top, similar to granules, but not the same. And then there's an asphalt flood coat that allows you to embed those granules into the top surface. Roll roofing is basically like a giant shingle. There's typically if it's modified bitumen, there's a base sheet and a cap sheet. You can have rolled roofing that, they used to have rolled roofing that function the same way shingles do. There's one layer of covering except where the sheets overlap, and the next roll would be adhered over the lap with roofing cement that you don't have any nail heads visible. So that's a single ply roll roofing, and then you have more. I don't see a whole lot of single ply roll roofing used anymore. It's pretty cost negligible to just use modified bitumen and have a base sheet and a cap sheet. Why shingles deteriorate? There's a bevy of reasons, really. They're designed to withstand decades of exposure to elements, but their actual service life depends on a complex interaction of environmental stressors, installation quality, and maintenance practices. Understanding the primary causes of shingle degradation is fundamental to accurate roof assessment, right? So you got weather-related deterioration from the sun, from rain, from wind, from hail. You got physical impact damage from trees, footfall, and debris. Installation defects that will accelerate wear or allow water intrusion. Nailing is a huge one, which you're not required to look at because you'd have to displace the shingle a little bit to be able to see that nailing pattern. Ventilation is a big one that will cause the roof to overheat. Manufacturing defects. Each of those factors leaves a distinct evidence that trained inspectors should be able to recognize and report on. And what you can see in the photos is basically an improper repair on that top middle one, where basically you've got a roof repair that was done where they used more modern laminated shingles in place of those 3-tab shingles. Those exposures are not going to match up, so they're going to be very difficult to nail in. I certainly wouldn't do that. It's a manufacturing, or sorry, it's an installation defect. You're going to build up excess heat, and those shingles are going to degrade pretty quickly. The ones on the bottom with those vertical tears, I would say that those are just vertical stress fractures, and they happen basically because there's a stair step method installation here. I'll quickly just show with a laser pointer that this shingle, this full shingle got installed. Then this split here is, sorry, this is a full shingle under here, and then this next one gets installed on top. And so basically, this shingle is a full shingle, this shingle is a full shingle. This is a 6-inch overlap of one shingle, and same thing here, where when these two expand and contract and are trying to separate and pull away from each other, this shingle is fastened to both of them, or not fastened, it's sealed to both of them because of the sealant strip. And so you got this fighting against this, it splits this, and it's happening a lot in this roof. It's really a manufacturing defect with the sealant strip. It's bonded too tightly to allow for movement when things are heating up. But it's something I would call out as a potential issue with the roof, but it's not really anyone's fault in particular. And then that middle one to me looks like fraudulent damage caused by a ball peen hammer. That is my guess based on the limited information I have in one picture, but as uniform as those impacts are, that's for sure not hail damage. So it's either a ball peen hammer or something else that is not hail related, but that's 100% not hail damage. And then you can see in the illustration in the bottom, when people talk about blistering, you have, there's no perfect asphalt manufacturing process. And so you get trapped volatile gases in the asphalt as it's manufactured. And in a poor asphalt manufacturing situation, you'll have a lot of trapped volatile gases. And then, so a lot of people think, well, the hotter the roof is, the more it's going to blister. That is not necessarily true. The all roofs that are poorly ventilated can overheat and degrade a little bit faster, but blistering is exacerbated and manifested by maybe poor ventilation or just being in a hotter climate. But the cause of it specifically is that there's a trapped volatile gas in the asphalt during the manufacturing process. That gas expands in heat. So again, a poor ventilation in a roofing system that builds up excess heat would certainly exacerbate that issue and cause those blisters to manifest themselves a little bit sooner than they otherwise would have. But even in a northern climate during a summer where the sun is just beating down on the asphalt, blisters will manifest themselves because of the manufacturing process, not because of the poor ventilation. Like I've heard it said a lot that poor ventilation is the reason those blisters happen. That's not the reason those blisters happen. It may be the reason why they manifest themselves sooner than they otherwise would have, but that trapped volatile gas is eventually going to make itself into a bubble and stress out the surface of the asphalt that it's trapped underneath and cause it to break at some point. Again, it'll deform the asphalt and cause an unpopped blister, even if there's not pressure inside that blister. The initial pressure will cause a permanent plastic deformation in that asphalt, and that asphalt will stay that way even if it never pops. And so that's just the reality of the situation with blistering. Asphalt shingle defects, again, you've got blistering, you've got just regular granulose, thermal cracking we discussed, manufacturer's defects, which a lot of times manifest themselves in flaking where you see exposed fiberglass matting, and then there's curling where the lower edges, the corners of the shingles are starting to curl up, essentially like bacon because they're getting heated so badly on top that the asphalt on the top layer is shrinking, causing the curling. And the opposite can happen where they call it cupping or clawing, where the underside is heating up faster and causing the underside to shrink while that overside sort of starts to cup over. Potential problem areas for shed roofs we talked about earlier. You may have problems where that structure attaches to the main structure, and valleys. Anywhere a roof changes direction is a potential for an issue. Inspection pictures of some asphalt shingles. Those top left ones, I know we've only talked about fiberglass matting. There is such a thing as an organic base mat. They've, to my knowledge, since stopped using it. I'm not aware of any being manufactured nowadays, but they were kind of bulletproof when they were brand new, but they used an organic base mat, which essentially was like a piece of felt paper. like not felt paper like your mom uses for arts and crafts if you're a 90s kid, but felt like asphalt impregnated paper so that they would use for underlayment. Well, they used that as a base mat, used the same asphalt impregnation process and coated it, and then they coated it with granules. But as you can see in that top left picture, especially if you're in the Northeast, like a lot of you guys in New York, New Jersey, Massachusetts, Vermont, Maine, Pennsylvania, I saw a lot of these inspecting up there, and they break up like potato chips. And you can see the ones next to them are probably a nice fiberglass base mat. They're newer anyway. I think it's a Certainty at Hatteras, which is actually a discontinued shingle, but this is an old picture. So you're seeing those organic shingles. The base mat gets waterlogged. It starts to break up and fall apart. You can see that there's an improper repair on that top middle photo. You've got face nails. That's never okay. Nobody should ever face nail and leave a fastener exposed, no matter how much caulking they use on it, because caulking is not designed to be exposed unimpeded to the UV rays of the sun. It's designed as a additional feature, as a added protection, and especially in interior spaces like kitchens and bathrooms, it may be used as the primary component of stopping water from getting into an area. But if you've got a roof that's heating up to 150-degree surface temperature, there's no reason that that sealant is going to be expected to be used long term as a solution. Again, if you go up on your mom's roof and she's got a leak and you need to paint some sealant on there until she can save up a few bucks for a fix, that's okay, but hopefully she can save up a few bucks in less than 6 months. The middle bottom photo, same thing. I think what they were doing there is, if you look at that top right photo, that's an asphalt manufacturing problem. And so it's flaking and releasing layers of asphalt very quickly, exposing that fiberglass base mat. And what some people will do, because they don't even know what that issue is, the roofer or the homeowner's looking from the ground and saying, hey, I can see like something reflecting in the sunlight a lot over the course of the whole face of my roof. The roofer or other handyman goes up there and goes, oh my gosh, I don't know what's causing this. The only thing I know to do is take some asphaltic roofing cement and just paint it over that. And so that's what you're seeing in that bottom middle picture. Bottom left picture, that top layer is obviously the roof covering material. It's an asphalt composition 3-tab shingle. Underneath that, in the inspector's hand, he's got one layer of roofing material. And what I mean by that is every roof should have a starter strip installed at the lower edge. And it's a particular type of shingle. A lot of people will just, if it's a 3-tab roof, they'll flip the 3 tabs upside down. But as you might imagine, when you start layering things on top of each other, at the headlaps, you have up to 3 layers of shingle in a normal roof installation with 1 layer of shingles. Well, at the very bottom, before you have anything to go off of, that first layer is going to kind of sit down a little bit funny. So they put a starter layer there so that that first course of shingles has something to seal down to. And so the inspector in the photo has the starter layer and the main layer of shingles pinched in his fingers, and yet we can see shingles underneath that. That is a good indication that there's 2 layers of roofing material on that roof. And another place to check that would be at the rake edge and see if you can see more than 1 layer. And then the bottom right is just moss growing on the roof. There's a lot of algae buildup there too. Anytime you have moisture sitting on the roof for a long period of time, the north slope is going to be pretty famous for this, because that's just where it doesn't get as much sun exposure in the northern hemisphere as the other slopes do. I know that the sun seems to go up overhead, but it has a southern kilt to it. So the northern slopes get the least amount of sun during the day. And so the organic materials don't build up there quite as fast. They need it to be kind of cool and damp for long periods of time. Again, think about mold, functions the same way. Slate tile roofing. I don't know why they have this other concrete tile on there as well. I know that looks like clay. Clay technically and concrete are very similar in their makeup, so it might be splitting hairs, but that is a concrete tile. And then you've got slate on the middle inspection photos. They're very good roofing systems. They're going to last for a long time, but because of that, they're going to go through periods of deferred maintenance where you've got things broken and things that should be getting fixed that are not getting fixed. They really shouldn't be walked on either type of roof that you're looking at here, because the barrel roof has a lot of gaps underneath it, and so a lot of pressure. Even if you're walking on the headlaps, you got a good chance of breaking those tiles. And then slate tiles, some of them are thick and they're very easy to walk on. Some of them are thin and you'll break them every step you take. And no matter what thickness they are, you'll probably break them if you don't step on the headlaps while you're walking on them. And if you have a lower slope one, you actually have a better chance of walking on it because you have that minimum headlap of 4 inches, whereas up, 812 to 2012, you got a 3 inch headlap. It's a smaller area for your foot to fall, and so it's a little bit easier to break those tiles. Clay and concrete tiles, they're very similar from an installation perspective. They're installed in generally the same way, and they tend to exhibit very similar problems. They're both made in similar sizes and shapes, flat, curved, corrugated, and they may or may not be an interlocking design. In most cases, tile designs are produced to be installed as ridge caps and other used in specialized locations. Both clay and concrete tiles have a long lifespan. Problems other than those from mechanical damage tend to be from failure of the underlayment and flashings rather than failure of the tiles themselves. Again, these tiles, you can make walkways out of them and they would last you forever. But if they're put on a roof, they're just going to be subjected to some other things. You've got that glazed clay tile on the upper right, looks like a concrete tile on the upper left. And you can see those concrete tiles, you've got that same Spanish look as the clay tiles. You've got corrugated or curved ones, flat ones. They make them in all different shapes and sizes. I think the main thing is, unless you're sure, I really wouldn't walk on them. Concrete tiles or clay tiles, I would never recommend that you walk on. They're dried out a lot more than concrete tiles when they're made, and so they're a little bit more brittle, much harder to walk on successfully. I wouldn't really recommend it. Concrete tiles, depending on the thickness and the shape, if they're lay flats or interlocking ones, again, if they're interlocking, it's a little sketchy. You don't really want to walk on those interlocks because you put pressure where there's a gap and you could break off the tongue. But, use your best judgment. If they're very thick and they feel sturdy, walk on the headlaps. Otherwise, stay the heck off of them. And the good news is they shouldn't be failing too much out in the field areas unless you can see that something's broken and laying out of place. But look in the change of direction areas. And then asbestos cement tile. Don't walk on these. If you break them, they wind up in a friable state. You might have not only the homeowner and the potential buyer on your hands, but then you'll have the EPA breathing down your neck as well. They were a very common roof from the 1930s up to the 1960s. A lot of homes back then had asbestos roofs, and they had asbestos wall coverings, and they had asbestos insulation around their HVAC pipes. They're very thin and they become very brittle, and that makes them so susceptible to damage that I would never recommend walking on an asbestos tile roof. Those diamond-shaped ones are usually asbestos. You can call it out by design if you're confident to do so. Otherwise, you recommend having it tested. And, at that point, if there's a roof issue, there's a special process. Again, like I participated in a job where they quoted $90,000 just to remove the roof. That was before the new roof went back on. $90,000 for, I think, a 50 or 60 square roof, just for the mitigation team to come in, suit up in hazmat suits, and properly dispose of the the asbestos. Because again, they have to remove them one by one carefully because they can't just go in breaking them all up, because you put it in a friable state where it's in its most dangerous, and then people can breathe it in, and that's a hazard that the EPA really wants. They'll be mad at you. Yes, Norman, gusset plates will always be metal from the factory, unless Noah built them. Wood shingles and shakes. We'll talk about them really quickly. We'll just kind of breeze through. Shingles and shakes should not be used interchangeably. Shingles are manufactured and cut on saw cut on both sides. Traditional shakes were hand split. They're not usually hand split anymore. They're usually machine split, and they usually have a machine cut on one side with an irregular shape on the other side, just to kind of maintain that storybook look that people really enjoy. So shakes are usually a good bit thicker, and they're a little bit more inconsistent in their shape. And when you have shakes, because of those inconsistencies, your normal underlayment has to be installed as interlayment when it comes to shakes. So that's one of the primary differences in the installation of shingles versus shakes. Shakes are going to have a layer of underlayment in between every course of shakes because they're irregular, so there's a lot more gaps in places for water to get in. Shingles are a little bit more uniform. You use underlayment in the installation of shingles. Flat roofs with the roll roofing, like we said, you can have hot mop or torch down. There's a bunch of different types, but the main thing on anything with seams or protrusions, you go to the places where things are changing. Seams, see if those seams are intact and seems like they're leaking. Built up roofing we talked about. It's going to have some kind of a roof deck. You're going to have insulation and cover board, and then there's a bunch of plies or roofing material. It's very hard to detect leaks on this stuff, and it always looks like trash by the time you're looking at it. So, don't call out every single thing as a defect, but try to find the seams like that upper right-hand corner. And again, the lower middle one, obviously, that's an aged roof that's starting to deteriorate. Membrane roofs, membrane is just the name for any of those single ply roofing materials, EPDM, TPO, PVC, any of those types of things. That membrane is supposed to be impermeable and not allowing water into it. So that's going to be your low slope roofing materials. EPDM stands for ethylene propylene diene monomer off the top of my head. And it's rubber. People call it rubber roof. When they're saying a rubber roof, it's EPDM. Don't make the mistake of saying if it's black, it's EPDM. If it's white, it's either TPO or PVC. There is such a thing as a white EPDM roof. So be sure when you're going to make those statements. Inspecting EPDM, seams have weak points, and a lot of times at those vertical walls, you'll have what's known as bridging, where the whole material on the face of a square wants to shrink over time. That's the biggest problem with EPDM is it shrinks. And a lot of people will think, well, flat roof, right? Like EPDM, it's rubber. I mean, EPDM, TPO, PVC, these things probably last way longer than shingles, right? No, an EPDM roof is designed to last 20 to 30 years. It's not supposed to be left on there forever, and it will start to dry out and shrink. And as it shrinks towards the middle, it'll have vertical walls, and it'll start pulling away from those vertical walls towards the middle and exhibit what's called bridging. I don't know what another term for it would be. I've always called it bridging. I call it bridging in my reports. Feel free to call it bridging or research another term for what that would be called. But the effect is that it's shrinking towards the middle of the roof, and it's installed at a nice clean 90-degree angle at roof to wall transition areas or roof to parapet wall transition areas. And as it shrinks towards the middle, it pulls itself out of that nice 90-degree tuck, and there's a big air gap left at the corner of the parapet wall. And that's not good because if anything hits it, it's very easy to tear. Waterproof a flat roof. This old house, I encourage you to look that up on YouTube on your own. Very good video. Vada is a vented roofing system. Again, really fun to look up. Good stuff on. There's a lot of modern low slope roofing solutions that are really, really good. Metal roofing, you do have metal shingles, and a lot of them are granulated, but mostly I would say they come in either sheets or similar to how gutters are manufactured. Standing seam metal roofs are manufactured in unlimited runs, basically limited only by the length of the roll you have on hand. So that gets installed. They're usually seamless, and then they're hidden fasteners. But the ones that you're normally looking at, if you see exposed fasteners, then that's an exposed fastener system. If you see no exposed fasteners, it's usually going to be a standing seam hidden fastener system. Standing seam, as the name suggests, means the seams stand up, and usually you'll have a bracket that gets installed, screwed down, so that gets screwed down right at the seam, and then the next panel will have an overlapping interlocking mechanism at that standing seam. And you can see that that's what that gentleman is using in the picture in the lower left there. He's crimping the standing seams. So standing seam is not a new system. A lot of old farmhouses do have standing seam metal roofs, but the most modern, really good looking metal roofs that last a long, long time are standing seam. And then you've got that absurd copper roof with welded or soldered seams on the upper right photo. It will be green in a couple years, but it's a very neat idea. Roofing oddities, you got plastic corrugated roofing, you got glazed roofs, you got plastic tile roofs. Thatched roofs is an actual thing. I mean, even in wet climates, especially in Great Britain, other areas of Northern Europe, thatched roofs have obviously been used for centuries. You probably saw some thatched roofs if you ever saw the movie Braveheart. It's a respectable roofing system. And frankly, they're actually making at some of these roofing trade shows, if you ever are interested enough to go to some of those or watch them online, they have a thatched roof that installs like a tile roof where it's got a nailing flange on top and then thatch. And honestly, it's mega hail resistant and it doesn't leak almost ever. You get that live green roof up there in the middle. Roof inspection with Jim and Mike, again, available on nachi.org. Drip edge. This is a contentious topic because it's not required in every jurisdiction, but it's required in some, and some jurisdictions have gone back and forth. The International Residential Code has gone back and forth as to whether or not drip edge is required. As you might be able to see, the design for drip edge is really primarily to protect the plywood sheathing because you want to create a situation where the water that's slowly dripping off the roof does have a tendency to run back underneath the surface of the shingle. And if there's no drip edge there, that water will touch the plywood and the plywood will wick it up, eventually will rot out and will create leak issues. Ridge and hip flashings. You can see that on a tile roof situations or any modular roof system, or really in any roof system, the ridge or hip flashing is usually made of, ridge cap, hip cap. They're usually made of the same material that the primary roof structure is made out of. Valley flashings, there's very, very different ways of making valleys. You can see the guy on the left is doing what's called a California cut valley. He's got a piece of metal laying down there so he can cut down the length of that valley. The guy in the middle is doing a woven valley. And then the one on the right up is an open valley. And you can use that configuration for shingles as well. You just have to be aware that you'll have to seal the outer edge of that down to it so that no water can penetrate up. Valleys are one of your biggest weak spots, so I would recommend definitely taking pictures of the valleys as you go. Roof-to-roof flashings, you've got slope transitions and other areas where you're transitioning from one part of the roof to the other. Anytime a roof changes direction, has a penetration, anything, that's a place where you're going to need to take a look, including roof-to-wall flashings where you've got a transition from one place to another. You're always going to have an issue there. Those are going to be the places where your issues are. It's not going to be out in the field area. And you can see one of the big hot buttons with roof inspectors being able to call things out. A kick-out flashing is recommended whenever you have a roof-to-wall detail and the wall extends out past the edge of the roof because the wall cladding is going to have a hole cut in it and the water is going to be able to penetrate behind the siding if you don't install a kick-out flashing. Chimney flashings function much the same as any other roof-to-wall flashing. You need to have a cricket if the chimney's wider, or 30 inches wide or wider. And it functions the same way as a masonry chimney would function the same way as a masonry roof-to-wall area where you need to flash it correctly. Vents and other penetrations, these are the areas that you need to look at. All of these things are showing some kind of defect where they do not look good. The pipe boots are split and chewed on by a squirrel and other things. Whenever you see this sealant like just gobbed on there, no matter if it looks good or not, that looks terrible. It should not be that way, and that's a bad way of repairing a roof. Soffit and fascia, usually the passive ventilation you're looking at for under the soffit. The airflow ventilation at the soffit, they use these baffles to hold back the insulation so that it allows air to come through and ventilate through the attic space. The basic ventilation you see, typically passive, but you have active ventilation there in the middle. You've got a fan that's powered. Masonry chimneys, again, if you're going to look, we talked about this during inspecting chimneys and fireplaces and stoves. The roof is the best place to get a look at the place where you're going to have the most issues on the chimney, where you can see the broken flue liner, you can see the broken crown, the cracked cap, all these things. These are things that you need to be able to see from the roof and identify. Manufactured chimneys, a little bit different. Um, it's something that's sided and built with a chase around it, and the flue pipe is really the active chimney. Now, in the last 3 minutes here, I'm going to try to touch on roof inspection with a drone. Um, get your Part 107 drone license if you're going to be doing it to make money. If you're doing a home inspection and you're flying a drone, you need to have your Part 107 certification through the FAA. It's a great tool to use for very large roofs or very steep roofs and all these different things. But if you don't understand some of the principles that we already talked about today, then you're not going to know what to look for with the drone, and you're going to be accountable for the information that you include in the report. So you're going to include some really fancy pictures, and if you can't speak to what they're of, and if somebody else spots a defect that you didn't spot with that fancy camera, then you're going to wind up in a bad spot. So I fully believe in the use of technology with inspections, but I also thoroughly believe in being educated in whatever the old fashioned would be first, and then employing that technology. And then just some things to look for. Again, you can use clues other than the condition of the roofing material, like a pipe boot. You can see this O2 code tells me that that was put on there in 2002. That's just a closer look at it. And then look for signs of recent repairs. That's always kind of a telltale when you're doing real estate transactions. People are going to try to pretty up a house before they sell it the best they can. It seems to be human nature. I feel bad when it happens, but if there's a leak here, this isn't a very good repair, but they just said, hey, repair this real quick so we can sell this thing. And then looking for signs of degradation. One example that I like to use in my report is to detail whether or not I believe the roof is in the first, second, or third of its warranted lifespan. That being a new shingle, this being a very old shingle, and having a manufacturing defect where it's shedding granules unevenly. Just some things to look at. So that's the end of what I've got. Sorry, I ran right up to the end of time.